So, welcome back. Have a good seat. So, allow me to talk about the agenda for the entire conference, so you have a better understanding on what's going on in the next 2 days. So first, of course, as I'm here, we'll talk about a little bit about the introduction, and then we have a tea break, lunch break, and another tea break the next day. Later on in the afternoon, and the gala dinner is at 6 p.m., which is over here as well, same floor. So please come back. But you can start checking in at 5:30 p.m. today. And this is the schedule for tomorrow. And more importantly, the fun part. So if you are signed up for the guided tour, you will be meeting at the lobby at 12:20, and then this is the trip. And then please enjoy Taichung. So before I actually start, so why here this time? So Taichung is the middle of Taiwan, and it actually is where my family came from. So the Lin family actually came from Taichung. And the hotel you're staying in right now is part of our business group. And a lot of people wonder yesterday, say, Jim, like, why are we staying here? I said, oh yeah, because this is part of the business group. And more importantly is, if you sell sensor, you can actually make a profit and build a hotel. That's very, very important. So I know geotechnical vibration industry is really hard and tough, but seriously, you can make money out of it and then build a hotel yourself one day. Anyway, so let's talk about, I'll give you an insight about the industry and then what we have done in the past 2 years. So Sanlien, we have been growing. So the consolidated revenue last year is about 136 million US dollar. And then the year we had the conference back in 2023 was 112.4 million US dollar. And then as Sanlien, the sensor part is about 16.2 million US dollar last year. So Sanlien consists of two big parts of business. First one is a sensing business, as you may know. And the second part is actually semiconductor chemical. So we provide a lot of semiconductor chemical to a lot of foundries in Taiwan. And that consists about 84% of our total revenue. And 16% actually goes to the sensor part. So there are a few things I'll talk about what we have done. So the expansion in the US market. So now Sanlien has an office in the US, and we also have an office in Switzerland. And also we have been growing the product we make, the vibration product and geotechnical product. The CAGR is about 18.6% since 2020. So Jatai, you may say hello to everybody. So Jatai is now with us right now. So he's in charge of the expansion in the US. Oh, have a seat. And then our office is actually in Irvine, California, Southern California. And the company is called Rift Systems. I mean, the reason I named it Rift because Rift is a crack, and everything we do is crack. You know? If there's no crack, we will not be here. You know. Yeah. So, and then we are actually the distributor for GRUB system in the US currently. And then also we are selling a lot of geotechnical product or vibration product through the Rift system. So then this is the office. If you guys have a chance to go to California, please let Jatai know. He will be more than happy to take care of you. And second, another strategic move we made was we have an office in Switzerland right now. And it will be our R&D center. More importantly, it will be our backup center for the dot cloud and our server. Because as you may know, Taiwan has a lot of earthquake, and we have a lot of geopolitical interference in this area. Like our good friend China sometimes will always send jets and something. So we decided to have our server backup in Switzerland. Again, since World War I, World War II, Switzerland is the only country that did not get invaded. And then the power source and the water source, everything is really stable there. So that's the reason we decided to move our server, backup server, over there. So the realized part. So we have made a lot of progress in the past 2 years that we announced for the pALERT series, the Shake series, and then the pALERT and the recorder. And the only thing we are not doing too well is the geophone part. The G330 is still work in progress. Hopefully we can catch up. And then, of course, we have developed the tilt dot, rain dot, A dot, which is analog, geotechnical recorder, wireless one, and then you'll be announcing this year. Also, more importantly, the shake dot and VW Duck 16, which will be announced this year or in this conference. Of course, we have a lot of update on our software, the SunDust, the dot cloud, and the HAZAS, and WMS is for the geotechnical part. So beyond. So this is our family tree for the accelerometer or the vibration part of the products. So we really want to take care of before earthquake, during earthquake, and after earthquake. So this is our data acquisition part. As you can see, this is the alarm system, Cube, and PX01. And of course, datum is also a data logger for vibration products. And the analog part, we have divided into two sections. So this is only the sensor, and this is the all-in-one. So all-in-one means the data logger will be included. So this is the MEMS part, the SO3 and the Q332. And these are the FBA and geophone, and these just pure FBA, force balance accelerometer. And these one are the smaller type. The SS300 is actually popular in the elevator or emergency shutdown purpose. And again, we need to reinstate our mission as a company. So this is basically like the geographic of a vibration product. So the SS300, and then you keep going up, force balance, and the better dynamic ADC, or crystal MEMS. This is a typical silicon MEMS. And then, of course, on the real top is a broadband and weak motion part. And that part is not our interest. We are interested in making product along these family. So our market position is application use product. Like, for example, weak motion, you have to use it for geothermal or use it for like academia purpose. That's not our interest. Our interests are more into the actual application. And for the geotechnical part, we keep pursuing making new sensor. For example, low cell, earth pressure cell, and embedded strain gauge, and MEMS IPI, and then multi-point liquid level sensor. But more importantly, our dot series. So finally, we have a chance to show this picture, our dot family. So now, as we mentioned, we have the A dot, which is for analog, rain dot, shake dot, tail dot, WB dot, which is for Winston Bridge low cell purpose. And then the VW family, so dot 1, dot 4, and dot 16. And we believe that the VW dot 16 will be the killer application in this market sooner or later. The biggest problem with LoRa and Wyson and also Sigfox protocol is the transmitting rate is not big enough to transmit in more than 4 channels of data information. That's the reason world sensing, they only have 4 channels. Or Sensive, they only have 4 channels, so does Actual. But with the help of LTEM and NB-IoT, we are able to transmit information more than 16 channels. And these are the geotechnical applications we talk about, just for you guys' reference. So later on, Reid will share more about our vibration product, and Siri will talk about more about wireless data logger, and the last one, our software engineer, Johnny and Brendan, will talk about our new updates on our software application. So now comes the challenge part, and then the market trend of what we discovered in the past 2 years. So the key funding is, we realize that NB-IoT is a good technology, is a good communication protocol, but it also has its limitation. Because a lot of countries, they are actually in the progress of phasing away, maybe not that we're moving away from NB-IoT. But also, NB-IoT has a little bit challenge about the wire capacity. Because if you have one station, probably you only can cover maybe a couple hundred nodes. But NB-IoT has a bigger capacity for relying on more transmitter or receiver. And again, we discovered this problem in the past 2 years. And as a company, we want to be transparent and to tell you, oh, this is the issue we discovered, but we are willing to work with the issue and overcome the challenge. So if you guys have any issue and feedback, please let us know. We would love to hear it. So our approach is actually switching to LTEM or NB-IoT hybrid system chip. So back then, if you bought our DOT system, the chip maker is actually came from Simcom. And then now we are actually switching to another chip company called Nordic. Nordic is from Finland. And their chip is very, very powerless. I mean, they focus on a niche market. So their power consumption is less, and it's also hybrid system. So they have NB-IoT and LTEM on the same chip. And so that's our solution for it. So of course, IoT technology is moving forward, and we believe LTEM and NB-IoT is the way to go. So this is a little slide about the wireless communication protocol evolution. And of course, tomorrow Sara will talk more about it. I'll just give you a brief example. So people, we are very familiar with the 4G and 5G technology. It has been there for a long, long time. Of course, 2G and 3G is fading away. They are fading away. But what replaced them is the LTEM and NB-IoT. So NB-IoT and LTEM, they actually share the same backbone and similar technology. A little bit different. I will explain in a second. Again, and there's another part of the alliance, is the Sub-G alliance. And you'll be similar. There are Sigfox, Wyson, and LoRa. And people are really familiar with LoRa because of world sensing. However, there's a big hit in this market in the past 2 years. Sigfox actually filed for bankruptcy. It bankrupt already. So, of course, there's new buyer for Sigfox. So Sigfox is, I don't think there's a chance of coming back, but somebody actually took over. Of course, Wyson is also still limited, and the application mostly in Japan, and also in smartwatch or some very, very niche market application. But what we believe, and of course, LoRa is the only one that is still standing, and then people are actually encouraging to use this technology. So a quick flashback. So LTEM and NB-IoT, you can use the typical or existing telecom company antenna networks. But for LoRaWAN, you actually have to use gateway. You build your own gateway, so that which is higher cost. But of course, if you build your own gateway, you can use it in somewhere very, very, very remote. For example, mining application. Well, our focus is actually more for urban, suburban application, and I think that will be suitable for using LTEM. Yeah, so world sensing, they are still using LoRa. And then Sensive, of course, they are moving into LoRa, Zigbee, and actually is actually using Wyson. And the traditional Campbell Scientific, they still use wires, so cables. And a few days ago, actually, Geocom just announced they are moving into LoRa, so they have LoRa data logger. So actually, I think in the future, this industry for wireless sensing will be in two alliances. One will be NB-IoT, LTEM, and another part will be the LoRa alliance. I think it will be a very, very clear picture in a few years. And so what happened is, what we realized, the statement I just made is also proven through the revenue. So actually, they actually face some difficulty in the past few years. For example, their CEO, Nimanta, actually left the company. And now their CTO, Moby, is actually the CEO now. And Sensive is actually sold to Eddy Electronic. And then after they are sold, the revenue keeps going down. Of course, world sensing is growing. We believe their revenue, we believe, is about 20 to 25 million US dollar last year. Of course, Geocom is still the powerhouse. I think, from our guessing, is about 40 million US dollar last year. But more surprisingly, our product, the DOT series, the CAGR from 2021 to 2024 is actually almost 47%. So basically, our products pretty much double, and double every single year. I think, of course, I think we have good products. But second of all, most importantly, we believe that NB-IoT and LTEM is growing. It's growing in a pace that we cannot imagine. And then we will show some application in a second. And the LT, a lot of countries doesn't have NB-IoT, but a lot of more countries are adopting to LTE-M. And at this moment, we believe Sanlien is the first one that introduced NB-IoT LTE-M data logger to this market. So we believe we have a good chance to stand in this market. So this is the pretty much the geographic of the NB-IoT LTE-M portfolio. So some like for example China, they only have NB-IoT, and for both like US and Japan, they have both NB-IoT and LTE-M, and they actually it has been a very, very successful application lately. For example, in the US, they use it for pet monitoring. For example, your dog, your cat, they have a little tag on top and to tell you, oh, where your pet is if you get lost. And so it's actually replacing the traditional GPS tracker. They also use it on truck, like truck monitoring, where my truck went to. And also for agriculture, like you have like pig or like big cow, they will monitor their status of health. And in Japan, it's actually quite interesting. They actually put it in the backpack of the kindergarten and the elementary school student. It's kind of like a little air tag, but this air tag can go miles and miles and kilometers away. So, and yet, if you think about it, like there are millions and millions of kids in Japan, so this application actually work. So this is actually, and USA and Japan actually are the two countries that's driving the force of LTE-M moving forward. So, I mean, when we first adopt to NB-IoT technology, like when we first started this project with Chen, we had a debate, oh, should we use Zigbee, should we use Wyson, should we use LoRa? And then at the end of the day, we chose NB-IoT. But when we first chose NB-IoT, we were pretty shaky about it because we were afraid this technology or this protocol would disappear. But apparently it's standing strong and still and keep moving forward. So back to our statement earlier in the previous page, we believe that the whole world for wireless monitoring will split into two, NB-IoT, LTE-M, and LoRa. So that's our belief. And we see the market is actually moving in this direction. So of course, in China, they use a lot of NB-IoT for gas meter, power meter, water meter monitoring. And we are seeing that in the US and Japan, they are monitoring the power, water, and monitoring going into the LTE-M application. Yeah, so this is a little comparison between LTE-M and NB-IoT. So of course, LTE-M is a little bit shorter, but the throughput is actually almost triple as NB-IoT. So we believe this can be a game changer as well. Of course, depends on your monitoring interval. It can go longer or less, I mean, but it depends on your application. Another interesting news is world sensing. They are actually adopting to third-party gateway. So you actually, if the part of the LoRaWAN, so if you have third-party gateway, world sensing device can be connected to. But however, if you compare to the gateway or antenna, NB-IoT is still a lot more than LoRaWAN because the carrier company, the telecom company from all over the world are supporting it. So with that reason, again, we believe LTE-M is the way to go. So let's talk about future. So for the vibration part, we actually are working on what we call the F340. So the newer generation all-in-one force balance accelerometer. Also the G340. We have the G330, probably will skip it to make it to 40. And Reid will talk about the naming system. I will not touch too much over here. And the Datum F440 basically is a standalone data logger for force balance accelerometer. And the Q340, so the Epson, the MEMS company, of course, people known as a printer company, they actually announced a new crystal MEMS in the past, I think, year and a half. the resolution actually can go up to 140 dB. So that's the reason we call it the Q340. I think it's a game changer in the, of course, the strong motion market. But they still kept the old one. So the Q332 basically is 132 dB. But now they have the 340 one. So that's the reason we decided to go into here. And we actually adopt a high precision RTC. The drift, I think, Chen is 1 millisecond per year. 2 seconds per year. So if you let it stay there, no NTP, no GPS calibration, drifting 2 seconds per year. That real-time clock is really, really expensive. But we decided to adopt it for some application purpose. Of course, we will introduce multi-thread into our system and high dynamic ADC. I think this is the trend everybody is going to. Of course, if you are willing to, we are willing to help you to set up calibration facility if you request it, and we will be more than happy to do so. And the geotechnical part. So currently, we talk about the .16, also the shake dot, and there are a few things we're trying to do right now. The first one is the D dot, so which is a digital protocol. So we already got the protocol from Geocon, GeoSense, SysGeo, and then a lot more coming. So we are trying to, so eventually this data logger can connect it to their IPI directly. And second one is the temperature, humidity, and pressure dot. I don't know how to name it yet, but if you guys are creative, please give me some good name, because THP probably is not a good name. It doesn't have a vowel inside. So but we have a little sample you can see out there. It's kind of still prototype, so you can consist temperature, humidity, and pressure inside. And the reason we decided to go into this product is actually actually came from one of our customers, but I don't know if it's going to be practical in your area. So in Taiwan, the Ministry of Labor, because of global warming, is warmer and warmer and warmer. So back in 2004, there are only 90 days in Taiwan that goes up. We have an index called the heat stroke index. Basically, it's combining temperature and humidity, and you combine it together and calculate index. So if the index goes to, it has 4 levels. So if it goes to level 4, the construction site needs to be shut down. The construction worker needs to like go to some shadow and drink water. That cannot work. Back in 2004, there are 90 days in Taiwan, in Taipei, that goes over intensity 4. But in 2024, there are less than 20 days. I mean, there are only 20, sorry, correction. There are 20 days back in 2004. But now almost 90 days in 2024. So global warming is real. It's getting warmer and warmer and warmer, very, very hot. I'm sure a lot of construction sites are getting very, very intense. So a lot of time in Taiwan now, they decided to work at night instead of daytime because it's too hot. So this thing can be another, so we'll use this device and put it on construction site and calculate index and provide the construction company, say, oh, maybe it's time you need to rest. Because heat is actually worse than vibration and also sound. So that's the reason we decided to go into this product. Another one is the tip dot. So they're I think it's STI, right? The chip company, ST Micro, STM. ST Micro, they announced a new MEMS chip. It's really cheap, but the resolution is not as good as the ADXL355 or the Epson MEMS. But we believe it's a perfect application for lens light monitoring. So you basically have it's like a little dot inside, and then with a MEMS, if it falls down, that means lens light happens. So that is something we try to go into. And this chip actually consists of partially edge computing. So it can be a good application for it. And finally, the SDI12 dot. Because SDI12 is a very, very standard protocol. And we believe it, and also a lot of metrology instruments use SDI12, and a lot of industrial sensor as well. So we decided to go into this development. So in the next 2 years, hopefully, when we have our conference again, 2027, we'll have 4 of them complete and ongoing. Maybe you guys can provide us some great ideas. We'll add into the pipeline as well. And again, I mean, these two are very typical. The rechargeability is already there. And we are going to have, more importantly, the coverage upgrade. So LTE-M and NB-IoT hybrid together as on one chip. Yeah, so please visit our booth out there, as you can see, and learn more about it, and then ask ourselves and ask our guy, and hopefully we can have generate some great discussion and learn more insight from each other. And thank you. So my section has ended a little bit early. So let me look at the agenda right now. So supposedly I end at 10. So from 10 to 10:30 is a tea break, but I guess you have more time for tea break. But before I end, anybody have question for me? If not, you guys will have a long tea break. Okay, great. See you guys out there.
Good morning. I'm Reid, and I believe most of you had a great night yesterday. So with welcome party or something. Yeah. So we back here this morning, and I'm so honored to be here for the first session after Chen. Okay. So today I'm going to talk about the SMA case studies on product, system, and solutions. Okay. This is my outline today. So the first part, I was going to introduce the SMAs in Sanlien's product line. This will be a little bit like memory refresh. We talked about that 2 years ago. All right, and I have 3 case studies. I'll focus on different aspect: product, system, and solutions. And the last part will be how to choose your right product. All right, the first one is SMA. Jim just said, what is SMA? Do you know what is SMA? Terence, what is SMA stand for? So what is S? Storm, okay. All right, so N means motion, right? So A means Accelerograph. So some people may be very curious about what's the difference between a accelerometer and an accelerograph. So most of the time, people don't know the difference between it, and most of us sometimes when we chat, when we talk about business, we'll say, oh, accelerometer. But actually, in deep into themselves, it's been a little bit different. Okay, so meter, you have if you ride a motorcycle, scooters, or drive like an ancient, antique cars, you have like meters in analog. Some people like to see the needles coming from 0 and all the way to 180. I saw Jocelyn took a picture with the Porsche, right, car here last night. Okay, so people drive a Porsche, they don't like digital ones. Like to see the needles coming from this one. Okay, but this is a meter, and recent years when the technology improves, we change the analog into the digital, okay, with numbers. So you can see a lot of, there's a lot of motorcycle on the streets. Most of them right now are digitized. So you see the, digits coming up and down, okay. So these 2 are meters. So when you want to see the trends, okay, so you need something to draw the meters, from point to point. So you have a graphs. Okay, so when an instrument is able to record the numbers and transform it to waveforms or graphs, we call it always called the graphs. So Sanlien's products. So I'm going to introduce the Accelerograph today. Okay. So what features to be considered within an SMA? So the first one will be the capture high amplitude ground shaking. So we're not talking about a weak motion. We're talking about a strong motion. You can feel that. Okay. The second one is monitor and record acceleration, not the velocity. Okay, the third one would be the three-component design. Okay, sensing unit. Okay, XYZ or ABC or vertical, horizontal, whatever you want to call it. Okay, the last one would be all-in-one design in modern world. You know why I say the all-in-one design? Because previously people will separate the sensing unit, and the digital and the recording unit. But you know, recently people like to buy everything, you know, at one package. Yeah, so we design. Most of the makers in the world design everything, you know, in one, you know, housing, you know, package. Okay, common specs of an SMA. So the first portion will be the measurement will be 0.1 to 100 Hertz or above. The frequency response, all right? And for the dynamic range, needs to be 100 dB or greater, okay? And the sampling rate at least 100 samples per second, up to 1,000 or even 2,000. Sometimes some manufacturer, yeah, they make the digitizer 5,000 samples per second. And the most common data format we can see in the worldwide is mini seed, okay, or ASCII or SAC, okay. And the second part is high quality MEMS or FBA. So in other occasions, if we talk about MEMS for strong motion, people will laugh at it. Okay, they only trust, you know, use force balance as the high standard smart SMAs. But right now, just after Chen introduced it, you know, Epson actually developed the very high quality coarse MEMS, yeah, which can be competed to traditional FBA sensor. And for the measurement range, the full scale, so usually we talk about plus minus 2G. But sometimes when using a different application, we go from 0.5G all the way up to 4G. And there are some companies in the world that they even make, you know, smaller ones, 0.25G, or even the greater one, 0. You know, plus minus 5G. Okay, so you can see this specification, yeah, often, yeah, in the world. And various trigger modes and you know, trigger mode and continuous recording modes. I will include it, and also the edge computing. You know, not many company in the world do the edge computing. That means you put the algorithm inside the computer, inside the local machine. Yeah, some companies like to do very fancy and very complicated software. Yeah, but you need to transmit the data successfully from your local units to the software. Yeah, but what about if you have a breakout? If you have like you know, interrupted by you know, internet connections, you will lose the data. Okay, so we put more algorithm inside the units rather than using the software to do this kind of a job. Okay, and the power supply usually be 10 to 30 VDC, and right now people like to use web GUI, yeah, to do the configuration. Yeah, because people like me, I'm a sales, I don't know much about the programs, so I like to type the IP address and you know, password and a username and get in and to configure whatever I want to do. Okay, and the connection goes on the Ethernet or wireless or serial and lightweight it. Okay, so for CWA, for example, Central Weather Bureau, Taiwan, for the previous tender, they asked for the accelerometer SMA to be less than 25 kg. Okay, so right now you can find every stop motion units less than 5 kg. So this is a big difference. You know, the design, yeah, in the previous time and the current time. So these are frequently seen SMAs in the world. I believe most of you have seen it in your market. Okay, so I didn't put the name and the brand on top of it because they are famous enough. Okay, so these are frequently seen SMAs in the world. Okay, so review of Sanlien's accelerometer product line. So just like Jim just introduced, here's a memory refresh. So this is a Shake series. Can anybody tell me what type of a sensor it is? It's a meter or it's a graph? It's a meter, right? So these are analog. Okay, so analog meter Okay, so accelerometer. Okay, and how about this? The SDQD and Shake series SS300. These are digitized. So this is digital one. Okay, so digital sensor. Okay, so last, of course, they are all in one. Oh, that's Accelerographs. Okay, naming review. Okay, if you remember 2 years ago, the last page of Chen's presentation is the naming rules we make. Okay, I like this color, so if if you don't like it, I'm sorry about that. Yeah, so try to make you see it clearly. So I put a different color for everything. Okay, so after the family names, pALERT, Shake, and the pALERT. So the first is regarding the sensing unit. Okay, so S means main sensor. So Q means quartz, F means FBA. Okay, G means geophone. So you can tell the sensing unit's nature from the first alphabet. Okay, the second one, the second digit means the axis. How many axes are there in the unit? So 3 means triaxial. Okay, so 1 means uniaxial. Okay, so soon we will launch some special, edition of biaxial. Okay, and the last 2 digits means its dynamic range. For example, S03 is 103 dB. Okay, S300 is 100 dB. Okay, 135 means 135 dB. Okay, this is how we name our strong motion products. Okay, so Accelerographs inside this family, if to be matched the SMA requirement, so we have the Q332 and the F330. Okay, here is the spec comparison of a Q332 and the F330. So I highlighted something that especially Sanlien has different from other brands. And I will leave you, because you can see your presentation from the QR code, so I won't spend the time talking about this. Okay. Okay, so let's see the first case study, the Taipei Metro System SMA replacement plan. So this is the Taipei Metro line. It's just like the page I introduced you with the naming. It's so colorful, so beautiful. Okay, I like this one. But this make you, you don't know where you are right now. It's in Taipei City. So this is a factor for the Taipei TRTC route. Okay, the first line is Wenhu line. Okay, so it's started in 1996. So right now, the number of the route is 5. Number of stations is 117. So route length is 131.1 kilometers. And the passenger volume per year is roughly like 710 million. Okay, so there are 2 more under construction. I think one is this one, and the other one is like this one. So they will be, in operation within a few years. Okay, so TRTC upgrade plan. Okay, in 2019, we replaced 7 SMAs for these stations, the blue dot, with Q332. Because at that time, we didn't have FBA yet. Okay, so we spent a lot of time discussing the specification and to persuade that the performance of the quartz MEMS high-quality sensor is exactly the same as FBA, it's even better. Okay, so they took it. But for 2 years later, we have our first FBA sensors. So we decided to use F330, okay, instead of a Q332. So we replaced the 8 stations. So right now, all the 15 stations of SMAs of TRTC are all Sanlien's product. Okay, so this is the previous SMA, older SMA for TRTC. Okay, so you may know this one. It's a very famous Kinematrix Etna sensor. So these existed for more than 20 years. Okay, Okay, so in projects 2019, Q332, and 2023, F330, so we use to replace Aetna. Okay, so the data transmission protocols for old system is from the Aetna to the TRTC receiving server, and then output the GALS intensities and the decisions. Okay, so the protocol they are using is RTD, so it output counts to the TRTC receiving server. So there's a program to decode the counts into these information, and they use RS-232, the serial connections, okay, to them. So to us, it's a big challenge. Okay, why? Because all of our Accelerographs, SMAs, go with Ethernet output. So how can we achieve this one if the TRTC didn't want to change here? Okay, TRTC told us they are not going to change anything, yeah, regarding their receiving server and output results. So you have to match it. Okay, so the first thing we think is if we can persuade them to use Ethernet, everything is solved easier. Because we do edge computing, so our sensors can directly output the GALS into their program. So we don't need to do anything to convert the counts into it. But they say, no, we don't want this one. Okay, we want you to do exactly the same, the old system. So how could we do? We have to provide Ethernet to serial converting module, downgrade our sensor to more previous ones, and then problem solved. Okay, it took us sometimes to make the customer happy. Why? Because for the first year, CWA just changed the new intensity scales, so we have to reprogramming, yeah, for the TRTC. Yeah, but thanks, yeah, to our R&D and our engineers, they put a lot of endeavors, okay, to complete this difficult solution. So in 2023, it makes the things easier, much easier. Yeah, because we had already done this one in 2019. So for the last 8 units of 330, we don't have to do much to fix this one. Okay, so this is the emergency response system and the topology in TRTC. So 15 stations streaming data back to the server, and it output the LED indicator in their control center. They also receive the CWA EEW, which we call a regional earthquake early warning information, and to output the result to all the stations and the central stations. Okay, and this is the interface of their operation. So the TRTC, they use the weight decisions to make this earthquake, how big this earthquake is. Okay, so you can see all the 15 stations are triggered here with different intensity. So the final report is from the biggest one. So 5 out of n means 15. Okay, as long as there are more than 5 stations triggered, this will be treated like a real event. So they will pick the biggest intensity and the GAL value from the trigger station to be the report one. So this is how they decide if they're gonna stop the train or slow down or do some evacuation plan. Okay, so these are the actual site photo. We deploy our sensor. So this is the cabinet inside every stations. Yeah, some of them are actually very close to the train track. So always generate some environmental noise. And we try to change some parameters inside, but for one station we couldn't solve it because it's just too close to the track. So we proposed that they should change the location, and they took it. So right now, so all of the stations are pretty, precise. And right now, let's just play some the videos. Okay, this is our first
Sanlien
case.
Technology
We
is a
use
frontier
the
for environmental
products,
monitoring.
okay, to replace the older one and put the efforts of our R&D, yeah, to change everything impossible to possible. Okay. The next one will be the system. Okay, so Taiwan Railway, so TRC, SMA, EW upgrade. Okay, so this is Taiwan Railway route map. So, you know, Taiwan Railway, TRC, is one of the few island circulated routes worldwide. I know in Switzerland, you got circulated one, but Switzerland is an inland country, but not like Taiwan is actually an island. Okay, not even for New Zealand, they don't have like a train route like this. So this is very special for TRC. Okay, and TRC old system before 2019. Okay, so you can see the transmitting data flow is just like this. So the TRC has a fiber optic island-wide network, and the data goes into their Earth-1 system acquisition server, and then they also receive the EEW from CWA. It's before 2019. So the system looked like this way. So the old sensors here, from Tokyo Shoshin, okay, and the Standalone, it is also made by Sanlien 20 years ago, okay. So what we were asked to do for the projects 2019, the first thing is we have to maintain the old accelerographs, okay. The second thing is to ensure the safety. We were asked to establish a 2-of-2 voting algorithm in the power stations. Okay, and then in power stations we have to set a cut-off mechanism. Okay, in case the earthquake exceeds the threshold. Okay, and then we have to optimize the unconventional Earth-1 server program. Why do I say the unconventional? Because it's specially designed by one of the chief in CWA 20 years ago. Yeah, he did some special algorithms, some programs for TRC. So at that time, actually, TRC had their own server program different from CWA. Okay, so we have to maintain it. Okay, the last one is creating a web-based real-time earthquake information interface to match the current trend. Okay, so in 2019 we did just two things. The first thing is we put a cube on the power station, okay, to set up the Standalone, and for the redundancy, we install a pALERT. The redundant sensor, and we put the 202 voting algorithms here, okay, receiving information from the old SMA using RTD into cube, and then Ethernet to here. And then we enhance the Earth-1 data acquisition program. Okay, so in that year, so what did we do? We're replacing with pALERT if the existing Tokyo Shoshin SMA is broken. So they don't have they didn't launch the new tender for buying the new sensors, SMAs. So what could we do is to replace the old SMA with our pALERT. So in some of the power stations, the two SMAs are all pALERT, and they work pretty well. And we integrate RTD and the TCP with a new program. And then with Selenium Cube, okay, special edition, okay, to put the different algorithms inside to match the TRC requirements. And we're collaborating with NTU EEWS lab professionals for making the Earth-1 program better. Okay, and we're working with the designated ID company introduced by CWA to create the web-based information interface. Okay, and in second project last year, we were awarded by TRC. The mission is to replace the existing Accelerographs. Okay, and the second one is to renew the older communication cables with Ethernet cables. The older cables are all RTD, data format, so it's all serial cables. So in this project, we have to replace everything with Ethernet. And we supplied the data acquisition software, so to this project. And we have to pass the very strict SMA requirements regulated by CWA. And the last one is we have to compete against an international famous brand. Okay. So in this case, we supplied pALERT F340TR. It's a special editions we developed for TRC. And then we help TRC to make a TRC cloud, okay, in the following year, okay, this year and the next year. And then what we did is we introduced pALERT F340TR to TRC and the CWA. And we outsourcing capable work with a long-term trusted partners. Okay, we don't do that by ourselves. Yeah, we use the best solutions to provide the most professional services to our client. Okay, and we supplied additional s.r.l server and the SENDAS for the data acquisition software. And we sent our sensors to be tested at the Sanlien TF lab and the national labs. And we luckily we beat up the Nanometrics and the Tokyo Shoshin for this one. Okay, so after this upgrading projects, this will be the whole TRC earthquake emergency response system looks like. So here is the power station. Here is the train station. In every power station, we have a backup pALERT, and we're gonna replace the strong motion accelerograph here. And in the train station, some train stations have the strong motion accelerograph. Some do not. Okay, but all of them has a cube to receive the real-time information from CWA or from some sites close to the train stations. And everything transmitted back to server here, data acquisition using fiber optic and the Ethernet. Okay, so CWA here sending the EEWS information from the central server to TRC, and this is only limited to TRC Central before 2019. That means for the power station and for the train station, there were no original warning services before. Yeah, but after our upgrading in 2019, so for power station and the train station, they can receive a hybrid earthquake early warning information from the local instruments and from the government. Special edition for TRC. Okay, so I just leave this specification for you to review later on. And the data transmitting design is just like this way. So from the field station through the cube and going to the TRC network to the central server. Here we provide the SENDAS and the s.r.l in this one, and then send it to TRC and also receiving the information from Central Rail Bureau. And in this s.r.l server, we have this module, okay, 24-bit pALERT to EW. Okay, so from the field station, this is to explain how the data flow in. Okay, 24-bit pALERT to EW and exporting generic to import a generic into the s.r.l system. This is how the data flow go. And the new SENDAS interface, which will be introduced tomorrow by our R&D colleagues. But here I just reveal something right now. We can display 100 sensors, more than 300 channels, seismic channels display at the same time. So if you happen to have a screen like this one, you can display all the seismic channels at once. Okay, let's see how the earthquake early warning is broadcasted by CWA. Exercise countdown 25. So in every cube, actually we have this exercise countdown performance. So you can, from time to time, you can activate it to your, customer or to your colleagues, and get them to get used to this kind of, exercise. Okay, so you will count down from 5, 4, and all the way to 0, and by that time you should feel the shake of the S waves. And for this one, if we don't have enough time to receive the regional warning, so we have an on-site warning. So receiving from the local SMA. Yeah. Okay, so this is the second case study. So for the last one, it's called a solution because the system doesn't only consist of SMAs, it also consists of other geotechnical instruments. Okay, Jiansanpi reservoir is located here in the southern part of Taiwan. Okay, so looks like this. Okay, not a big one, yeah, but it is very precious for the water reservation. Okay, so it's a very old reservoir built by Japanese people back in 1938, and the son of a Taiwanese engineer. So the dam type is earth dam. The owner is Taiwan Sugar Company. Okay, the main purpose of this one is the cooling water for the sugar manufacturing machine, and also for irrigation, which is agriculture. Okay, and its spillway is the overflow. It's a natural spillway. So when the water exceeds the limit, it will flow out naturally. So it's no control gate. And the max capacity is 6.33 million cubic meters. But right now it's only half because of the accumulation of the sand and also some of the mud. Okay, these are the old SMAs in most of the dam in Taiwan, 20 years ago, 30 years ago. Most of them were the brand of Tokyo Shokushin. Okay, so the challenge and the solution is, the first challenge is the Taiwan Sugar Company always complained to us they didn't have enough budget. They have to earn the budget from other divisions. Yeah, so we keep pushing them for 3 years. So you need to be very patient, okay? The second one is all the instruments and the monitoring interface. In the first time we met with them, they said we want to keep the old monitoring interface, and for all the instruments, if they could still be used, yeah, they want to keep it. So we spent a lot of time to think about how can we make it, and we finally eventually found out it will cost us. It would cost us a lot of manpower and R&D energy to do this one, and the system, yeah, was not ours. Okay, so finally we persuaded them to replace it with a new design, hardware and software. Okay, and the previous contract, changed the tender specification after the tender was released. The interesting thing is, for the dam monitoring. The distributor for Tokyo Shokushin in Taiwan has a lot of influence, to the project's owner. So originally, okay, the system was designed to be wireless, okay, but it changed to be wired. So that means we have to spend more money to rewire, okay, rewire the cable, okay, from the instrument to the central, okay. So we compromise. Yeah, in order to make the owner happy and in order to get the tender, okay? And the last thing is severe weather and not so helpful for project owner. They are very passive. And also the weather there can be like this hour is heavy rain and the next hour will be super heat, But how should we do it? We cannot hide, so we just do it. Okay, so this is our new system topology. So from everything, the server part, the instrument part, everything is new, including the cable. Okay, so that means we spend everything to tore down the older system and to build up the Sanlien solutions to this reservoir. So this is where the instruments are located. Okay, so we have 9 VWP, okay, and the 2 VW hub, and the 2 SMAs, 2 cube, 1 rain gauge, 1 radar water level gauge, and 1 tilt meter, and 1 server. And this is the site photo, yeah, when we do the installation. And this is the water level, yeah, VWP. So we have 9 holes here, okay, 3 on this part and 6 on this part. And we have one water level, radar water level gauge to measure the water level from the near the spillway. And we also have two strong motion accelerographs to measure the real-time shaking information. So you can see the actually the live waveforms from the interface. Okay. This was the one typhoon coming to Taiwan last year. And what is interesting for this typhoon? You know, we in 2016 we had our first female president, right? So in her presidency, there wasn't any typhoon landing in Taiwan. So she's a lucky lady. Yeah, just the new president just stepped on only 2 months. Okay, so the first typhoon landed in Taiwan, and in that summer there were totally like 3 or 4 typhoons landing in Taiwan. So this was the first one. You can see, yeah, every typhoon is like a super typhoon nowadays. Okay, so this caused a lot of flood and the damage is landslide, around the southern Taiwan. Interesting is the eyes of a typhoon actually coming to the south, but here in southern top of Taiwan suffers most of the disasters, floods. Okay, this is the garage for buildings. I think it's 4 stories all the way down, so full of water. And this is the street view of a Kaohsiung city, just like this way. I believe this should be like a Tesla, so it can still run in the water. Okay. Okay, so we measure. Okay, so our system, reflects the actual measurement, value to this typhoon. So you can see the level change of the VWP, okay, going up in this in this time, and then also the rain, changes, okay, in this time, and also the radar water level, changes in this time, okay. So you may feel a little bit strange. Why the water level drop down here and then go all the way up here? Because this period actually there was no data. Why? Because the whole power supply panel was in the water. Yeah, it was floated. They just established the power panel too low. Yeah, so that's when the flood came, they couldn't do anything about it. Yeah, so 1 week later we went there and fixed up everything, so you can see the data after this one. Okay, and this is a real earthquake event. Yeah, just 1 month ago. Okay, so you can see the small one is really close, okay, to this reservoir. We recorded the waveform beautifully. And this is the one happening just 2 months ago, early this year. Yeah, it's one of the largest happening this year. It's also here in Tainan City. So this is these are the shake maps from CWA, intensity map, shake maps. And I believe some of you may have the chance to see this one before from the X, which is Twitter, okay, or the Facebook. This is our national NTU campus array. The dot here, more than 800 stations are all pALERT. Yeah, the small sensors. So the pALERT can provide the near real-time shake maps, just 1 minute after the earthquake happens. So you see. Okay, so beautiful. Okay, so PGA, PGV, intensity, and also SA 1.0. So these 4 shake maps are critical if they are sent to the local government or some decision maker authorities. So they can know how to put the resources into this kind of the disaster. Okay. Okay, for on-site warning. Okay, we also set up real-time push messages to our client locally. So because the earthquake happening here, so they don't got the time to receive the earthquake early warning information from the Central Weather Administration. So the only thing they can get is this. Okay, so the real event. So you can see the PGA is 710 gales. It's crazy. It's almost the 0.8 G. Yeah, in this event. and the velocity is 52 centimeter per second. But if you are away from the epicenter, you will get the chance before the S wave strikes. You will receive the countdown through your apps. Okay, intensity 4 minus 16th. And during the earthquake, you receive exactly the same thing as I just showed you. And after the earthquake, you receive the earthquake report. Okay, so this everything is provided by Sanlien. All right, just show you the video of the dam. This dam now is a recreation area, so they have hotels. They have a place to do the camping.
Sanlien Technology, be the frontier of environmental.
All right, the last part will be how to choose your Mr. or Mrs. Right, based on the different category of your project. So I just separated the target and the model, which can provide you for some reference. For example, if you are just doing some simply control, or you don't have too much budget, you can choose our SS300 seismic switch, or pALERT can also do the trigger, the shutdown purpose. And if you don't have too much budget, but you want to build up an earthquake early warning system, I think the pALERT and the PS300, which is the pALERT second generation, will soon be launched this year. You can choose these two models, as your primary target. And if you want to do the comprehensive EEW, for example, if you want to establish the system just like we displayed outside with weather stations and in the building with the sensor, vibration sensor, and other type of a sensor, you can choose S303 or Q332. But if you want to do the complete EEW, or more like a scientific seismic monitoring system, you can choose the high dynamic range models, for example, Q332 or F330. And if you want to do the cable state bridge monitoring, so you use uniaxial FBA, triaxial analog FBA to go with our Daten data logger, and or SD300. This is PoE sensor. Okay, so you can only cable the sensor with one wire, so easier for you to deploy the sensor. Okay, if you want to do the smart SHM, you can choose Q332 or the PoE QD332 or F330. So the last one, DAMs, of course, all of our Accelerographs, you can choose to use them. Okay. So industrial safety. So this is the topology sample for your reference. So two of the three voting system looks like this. Okay, so we support SMS or Telegram. Right now, the line is going to charge the customer to use it. So, and the line is not so popular in other countries. So we use Telegram to replace the instant push message. And the total monitoring hybrid environmental system, just like we displayed outside. So you have a weather parameters, for example, like temperature and humidity, wind speed, direction, and also the rain. Okay, all of the parameters can go to cube at the same time with the seismic dynamic monitoring, and the data can be uploaded through FTP to your own server, okay, or to any places you would like, or to the local server. And if you do the SHN, so the most simple one is HAZAS, okay, so the quickest damage response system. So you only need 3 sensors to deploy them on the ground, the top, and the second floor. So every time when an earthquake happens, the cloud can tell you if your access is safe or not. So what are our advantages? Okay, these. Okay, from top to down, and the last one will be the quarter for today. Okay, so Sanlien and the clients, and becomes a synergy with success. So can anybody tell you what is this blank is? Jocelyn, what is the blank is? What do you think? Yeah, that's you. Every one of you here is our most valuable, partners, VIP, VVIP. Without you, there will be no synergy with success. With you, yeah, the success will come. Okay. Thank you very much. Yeah, hi. So, any questions?
We are Sara. We are located in Italy. Most of you probably know our company and what we do. We are making almost all range of sensors and data recording devices for weak motion to strong motion. More focused on seismology, more focused on weak motion. And what I'm showing you today is a solution we applied for a gas storage plant located in the Marmara Sea. Normally, in gas storage plant or any other mining activities, you are in the risk to generate earthquakes, small earthquakes, or unfortunately sometimes big earthquakes. So it's so-called earthquake-induced activity, earthquake-inducing activity. So if you pump at high pressure gas, like CO, for example, for CO2 sequestration, or if you pump fluids, like for geothermal applications, in the pumping activity, which are very huge, which are very big, and involve large areas of the reservoir for geothermal, or, for example, even natural gas extraction, or storage of natural gas, you are involving a lot of volume inside the underground, and this is a dangerous situation for both aspects. One is economical aspects, because if imagine that you are storing natural gas underground and you have a crack in the reservoir, then you have a leak, so you lose some of the gas. And in the other case, for safety, because if you induce earthquake, that can be a problem for the population living nearby. In Italy, we have quite a lot of industry for natural gas or storage, geothermal, etc. And in this case, we have regulations in Italy which every mining, I don't remember how to say in English, but any place where you make a mining activity have to be monitored for safety reason. And so we get some experience in implementing this type of devices, this type of network. There are small seismic network with maybe 5-10 stations for weak motion and for strong motion. These plants are often in urban area, near urban area. So we have the needs to record very small earthquakes, okay, on the range of -1 to 1.5 local magnitude, so very weak motion. And because the very small events give an idea to the geophysicists of what is going on underground. So the needs is to have very sensitive devices and in a better location. Here you see, for example, what happens in the urban area. So this plot is a 7 days, so 1 week plot. And you can recognize that this is the frequency and this is the time. The colors gives the idea of the intensity of that frequency during the time. You can see here at low frequency, because this is 0.1 hertz, so this is 0.1 to 1. In this area, you can see a storm passing by, because a weak motion sensor can detect even the variation of the pressure over the crust of the earth, can detect the motion of the sea waves. Even if we are located in the central Italy, we can see our sea, the Mediterranean Sea, Adriatic Sea pushing on the earth. So this effect is caused by the atmospheric variations or weather variation. And what is going on from 1 hertz to up, so 1 hertz, 10 hertz, 20, etc., focused in this squared area, are the urban noise, so the anthropic noise you find in the ground. You can see very clearly the variation during the day and the night, day and night, and also you see here the day of Saturday, the afternoon Saturday, Saturday afternoon and Sunday. So the variation is very, very high. So the idea is to detect low intensity earthquakes. You need to go in, and you have to detect this in an urban area, is to go underground. So to go underground is very important, and we use normally borehole sensors. What this slide shows? This slide shows the intensity of magnitude 0 to 1 for 1 year in Italy. So you can see these small earthquakes are located particularly where the faults are. No? You can see these yellow lines are the faults, so the seismogenetic places, seismogenetic sources. And you can see central Italy has a lot of small earthquakes. We are located here in Perugia, not visible because the name of the city is overlapped by the plots. And we have here a huge representation of small earthquakes. Why? Because here the network, the national network is very dense. In this area is less dense, but is not represented in the national catalog. But you can see also that here seems that you don't have any small events. Is it true? Well, this plot shows the earthquakes from magnitude 3.5 to 4.5. And everybody knows a little bit about seismology, can say that when you have an earthquake, the magnitude of this magnitude 3.5 and over, you for sure have also microseismic, because it's impossible to have big earthquakes or major medium earthquakes without having microseismic. So if you compare the two plots, you see there is some discrepancy. So you have an area where you don't have microseismic, while you have big seismic. This is the symptom of lack of measurement capability. So to improve this measurement capability, Italy is also focusing on this to cover these areas where the seismologist believes there are microseismic, but we are not capable to see. As I was saying before, one of the solutions is to put the sensor in the borehole. In this case, this project, exactly of this slide, is regarding this gas storage plant in Turkey, in the Marmara, near the Marmara Sea, because below the Marmara Sea there is a gas storage plant. And so the company running this storage plant wanted to see the microseismic. And 3 stations has been installed onshore, so on the land. There are boreholes, they put the sensor there. but they want to go and see what happens, I mean, in the places where there is no possibility to detect. So they put a sensor on the sea, offshore. So we have been inquired to provide a solution. So we think to have a solution like this. So we have, the seismometer will be on the seabed. We have a buoy. The buoy is connected to this stabilizer or this ballast which keep the buoy on the place. And the seismometer has an umbilical cord going up, having communication and power supply. Of course, this is feasible where the seabed is almost flat, and is feasible where the seabed is not so deep. But in many cases, near the coast, you can go probably 10 kilometers, 20 kilometers off the coast and maybe find a place where this is possible. Having so the possibility also, being nearby the coast, to have coverage of the mobile phone, so you can also guarantee communication. The first problem was the designing of a cable, so suitable cable. So marine cable are in use about some decades because the marine application, it's even only for the communication, was already done in the industry. So, but we redesigned a cable, suitable cable for this, that have to face several issues. For example, the saline water. So of course, this water in the sea is saline, so the salinity of the water. The tensions, because the ocean is always, the sea is always in motion, and also the self-weight, it had to be not heavy and not too light. It could be prone to fish attack, and the wave motion is continuously, can generate friction, etc. So we designed something that we will see how much it will last during the time, because this has been deployed 16 months ago, something like that. And so this is one of the sketch of the design of this cable. The cable is made of an outer jacket, very robust. There is steel, also shield, not as shield, but is a structure to protect the inner of the cable. This is the cable. So this is the outer jacket. We have a steel, stainless steel, to protect the another jacket would be another barrier if, for example, a fish attack outside and make a hole, so the water could not enter, possibly. We don't know. We will see during the time. And then the core of inside with the electric shielding, etc. This was the sensor. The sensor is reused, the same sensor we have developed for borehole. So the sensor is containing a broadband sensor, velocity meter, so weak motion, with the marine cable and with the proper connector on the head. This is the inside. Inside this, in this point and around this point, there is this structure, which we have the sensing element, which is conical. It's conical because you can then, when you put the sensor on the seabed, it can have some tilt. So the conicity allow to have the room to compensate up to 5 degrees inside. And on the top, on the buoy, we have the data processor, because yes, we call it data processor because the AD converters, the signal is converted digital on the seismometer. So we have a data processor, the power charger for the battery, for the solar panel, the junction box, and the communication is not visible in this picture. So the solution was to provide this big concrete block. This concrete block allows that the sensor is very steady on the seabed. This concrete block has a pipe inside. So in this pipe, we have put the sensor. Okay, this is the connector. So we put the sensor vertically in this pipe and buried with the sand. So the sand doesn't cement on the sea water because of the salinity of the water. And so it can be even retrieved by itself or retrieved the whole block if necessary. So the sensor you saw before, okay, is then buried inside this pipe, okay? Inside this pipe with the cable. The cable is anchored to the concrete block, and the concrete block is then steady on the seabed. Then this is the buoy, the bottom part of the buoy, the part which is go under the water surface, and this is a moment of laying down the sensor down into the water. Inside here, you see in this picture you see the concrete block which has this mark. This mark is the north. So the diver going down was knowing where the north, and it was capable to orient the block, okay, before making it touch the seabed. Later we get out the noise, I mean ambient noise from the seabed, and we found that this is the noise floor of the sensor, this pink curve, this is resulting the noise floor of the sensor, which is even lower than what we declare on the datasheet. And you can see clearly the 19 seconds period and the 5 seconds period very clearly, of course, because you are on the sea, so it's very, very big. There is some other noise which is not good, but is there because of the sea, of the waves, and maybe some of the motion of you have from the buoy, but it has to be accepted. Anyway, the instrument is behaving well as the instrument itself. Now we should probably have yeah. This is a video illustrating the deployment. And so you also see more or less the place. The place in Turkey, so the Marmara Sea. Four seismic station was on the sea and 3 on the shore.
Hortumu tutayım istersen yorulduysan.
So we had the diver had a body cam. So this is the location, more or less the location of the area, in front of Sea Libri. Was the picture of the preparation during the trip. You can see here the buoy, the solar panel of the buoy on the left. So the sensor fixed on the concrete block for the best coupling, yes. It was the man going down. The moment of the deployment. In that area, the seabed is around 20 meters, 20, 30, 40 meters. So it's not so deep, it's rather shallow. But the tightness is guaranteed for up to probably 1,500 meters, there is no problem. But then the problem is the cable. Here the diver was going down and guiding the positioning. He had a level, a normal level, bubble level. So he checked the leveling of the block. If the block was not too much out of level, it will be repositioned in another place. But it was more or less flat, so we were lucky. Now he's releasing the cord. And of course, the diver has the compass, so he can orient the sensor correctly, thanks to the yellow band. So this is the sensor deployed. And this is the buoy outside. Solar panel, batteries, modem, etc., as you saw in the scheme. the yellow cable you see going down. So this is the final setup. And then we were lucky because after the installation of the fourth sensor, we got a small earthquake nearby. So that is our case. I don't know if you have questions, I can answer. Thank you. Yes, there is. Okay, thank you.
Good morning, Mr.
Mauro.
Yeah, I'm Romano from s.r.l Techniques. Did you consider the sedimentary upon the installation of the block? So I saw your presentation that if you're going to install that near the shore, the sedimentary is very thick. So the positioning of the block can be tilt in the long run. So how are you able to control the tilting of the,
yes,
considering the sedimentary?
Okay. Yes, good question. Inside, maybe I can go back with the picture with the sorry. Oh, sorry. Okay, perfect. As I said before, the sensor has a capability of correct up to 5 degrees. So we have sensors in the sensor itself, which control what is the tilt. And if there is too much tilt, there are motors inside here. You can see this point, which can level this platform. So this platform can be leveled and corrected up to 5 degrees. Of course, if the tilt becomes too high, the diver has to go there and reposition. But we can keep under control the tilt and eventually compensate if too much. Until now, we have not seen any difference on tilt because also depends on the stability of the seabed. You're right anyway because there are a lot of sediments.
Correct, because normally the thickness of the sedimentary comes from 3 meters to 6 meters thick.
Yeah, but we can do many about this.
Have you tried testing it using a vibrocore first before positioning it?
No, in that project we was not planned to make this kind of test. Okay. We run some tests regarding using the HVSR methodology to evaluate the thickness of the place, and I can say that in 4 places the result was quite stable. So the sediments was rather compact according to the HVSR results. I don't have it here, I'm sorry, but in one of the 4 of them, I don't remember what, but one of the 4 was rather unstable. Yes, I can say. But this is our first project we make this way. So we are learning, and probably this wasn't one of the causes. We will see during the time what happens. Thank you for your question. If you have more,
that's a good answer.
Thank you. Thank you.
Okay, I'm Chen from Sanlien. I have 2 questions. One is from technical point of view. What is the sampling rate and the power consumption? The other is the project cost. How about the instrument cost, deploy cost, cabling cost?
The power consumption of the whole system is constrained more than the transmission of using mobile network because the transmission is real time. So probably the power supply, power consumption is about 4 watts for the modem, and the other system is around 2.3 watts. Okay. So we have a total of maybe 6 watts.
Okay.
6, 7 watts.
So the sampling rate? Sampling rate.
Sampling rate. Sampling rate is selectable by the digitizer. In this case, I think they record at 100 samples per second, but it can be set to 200, 250 or whatever. No, maybe, sorry. This is in Turkey, so they use a standard 250 samples per second. Sorry, I forgot. Because for the broadband, you don't need to sample to high.
Yeah.
But in Turkey, they have a kind of standard. They always sample 250.
Okay. The cost.
The cost. The cost of the deployment, I don't know, because it has been deployed not by us. It's deployed by our system integrator. And honestly, I never asked the cost. I can ask. If I remember correctly, 20 euro per meter, something like that. It's quite expensive. To take it out, you have to send a diver. You have to send a diver, maybe also with, well, if you have to retrieve only the sensor, that would be not a problem because the sensor is not so heavy like in the air. No, so the sensor is, the weight of the sensor is about 15 kilograms. So in the water, maybe it's about 6 or 5. So it can be retrieved by hand, by the diver. But if you have to retrieve the concrete block, you have to use a crank, during the deployment. Regarding the water tightness, it's you can see there are O-rings with stainless steel, of course, machining metal. And we believe that with this, for the geometry of the O-ring, etc., it could withstand the pressure of 150 bars, so 1,500 meters. But it is not the target of the project because this is for shallow depth, not so deep, I mean. But for the capability of the resistance of the pressure, the calculation is for that range. In this picture, you see also, maybe, I don't know how to enlarge, but this is, oh, maybe, let me see if I have another one. Well, maybe it's here. Anyway, this point where the cable go in the cable gland, it is quite nasty to prepare because you have to be sure that you know water leaks throughout the jacket of the cable. So the coupling of the jacket of the cable with the steel is quite a concerning problem, yes. So we use epoxy resin, gasket, etc. to. Yeah. No, when you get the sensor out, this portion you can detach, but you can only detach outside water, of course. So this is the cable connector. So this is a standard military connector. We apply it to our machined metal part. So the tricky part is to prepare this point, the cable going to the metal. Then you can detach, because this part is attached in this point. Sorry. You can see here. Here there is a key. So we tighten with a wrench this part. Then if you, I can show you maybe a better picture later.
No more?
Okay.
All right.
Thank you.
Good afternoon, everyone. Thank you, Mr. Jim, for the opportunity, and thank you, Sanlien. Today I want to bring you the updates of our projects from 2 years ago until now. This is the Mindotama and Sanlien 2024 projects, and some projects that we finished this year. Okay, let's start. So the agenda is how do we reflect on the past projects. We will highlight the success and also the challenges from our past projects, and we will practically use that experience to make our planning into the future. And we will demonstrate how experience from past project will drive our strategies for the next 2 or 3 years. This is the key topics that I wanted to talk about today. First off is the INA EEWS, which is the Indonesian Earthquake Early Warning System. It is the regional earthquake early warning system projects that we managed to get in the last year in November. The second was the update of LRT seismic detection alarm system, which is the on-site EEWS for the LRT system in Indonesia, in Jakarta precisely. The third one, maybe the most interesting one, was the BPI blasting monitoring and on-site EEWS projects. Since this is very new for me, this is for like a mining company and it's for blasting monitoring, so it's kind of new. The fourth one was Krakatau Posko, a steel mill company in Indonesia, near the West Java region. It's also for the on-site EEW projects. And the last one was the dam projects and also their communication system, which where we will explain about our dam projects, how do we treat their problem, and how do we uses the communication system. Okay, this is just the simple explanation on the Indonesian regional EEWS system, because I cannot explain most of them because the project has not been concluded yet. So a lot of them are still confidential. But this is what I can explain to you guys. So in 2024, in November, with the help of Sanlien and also some people from NTU, we, PT Mindotama Avia Teknik, manages to get regional EEWS projects that will create a backbone for the national EEWS, regional EEWS. We will start by implementing the regional EEWS on the West Java, and we will have the center on Jakarta and Bandung. This EEWS CISPRO project we also get by beating some of the big company like NEC from Japan and Gempa from Germany. So we are kind of excited to follow on this project. But this EEWS CISPRO project consisted for a few parts, which are the data collection, which is, as you know, the acquisition process. The second one is the processing system. The third one was the dissemination system, and the last one was the monitoring system. Let's go through this quickly. Okay, this is the EEWS current status. This is the development of the data collection software. This is what I can tell you. So we are in charge of designing, and we are also in charge to create a waveform data acquisition and blah 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 and the others. So basically, the data collection is we created a software and a server to collect the data from all the types of sensors, mainly the accelerographs and the intensity meters, of course, that we can use to be able to detect the earthquakes and then to activate the EEWS system. This is the development of the dissemination software. You can read the details here. But the dissemination system was basically how we divulge our information to our end user, not end user basically, but the people who, the stakeholders maybe. So as you know that we will be working with BMKG, and we will divulge the information that we get from the sensors, and then it will go into acquisition system, and the acquisition system will then process the processing data and will determine if this earthquake needs to be informed to the public because it was dangerous or not. So it will give some important information for the public if it was needed. If it was not, then it won't give any information, since maybe the intensity is too low or something like that. Then the information will come in from the earthquake center, not the EEWS division. This is the monitoring control system. As you can see, there's some additional stuff there, which is the parameter setting display and the system log display. That's mainly on the how to monitor the EEWS system, if it's working correctly or not, including the waveform that is coming from the sensor and the status of each acquisition softwares. For example, Apollo servers for nanometrics, and the Earthworm servers from to process the minisit data for the intensity meters from Sanlien and maybe from other companies from Japan like Meisei and etc. So this, yeah, I already explained about this. This is the data collection, which acquire the data from intensity meter and accelerometer. And this is the processing data, processing software, which will process the data that it received, and it will produce earthquake early warning information. This is the dissemination, which will provide warnings for the general publics. And this is the monitoring to monitor the condition of the EEWS. So this is the intensity meter, especially the pALERT series distribution in Indonesia. As you can see, it's there's a lot in western Java, and the island of Bali. So the initial planning of BMKG with this project is to create some kind of, not prototype, but the backbone of EEWS, the whole Indonesia EEWS, but we will start in West Java, with the center being in Jakarta and in Bandung. It's around here. So we will use the available sensors right now to prove that the original EEWS could help people and could be useful for people in West Java, especially considering that the earthquake will come from the southern part of Java. And as you know, the chief of BMKG always mentioned about the megathrust that is potentially could shake the southern part and western part of Java. So this earthquake early warning will be very useful for them to be able to give out warning before and shut down important equipment before the earthquake comes to them. So we are very excited to do this project, since this is put us in the regional EEWS club with Taiwan, Japan, and Mexico, and US, I think. So yeah. And the second part, maybe they will create an EEWS based on Bali, but that's still maybe just a plan. This is the accelerometers. Mostly this, because we only maintain the nanometrics equipment. So this is the mappings for nanometrics accelerograph. Maybe now they have Guralp and some other brands that we don't know about, but mostly this is the area that we installed nanometrics product, which, as you can see, most of them are in Java and Sumatra. A lot of them are in Sulawesi and in Papua. You can see the green one is when the sensor is working properly. The red one is, of course, when the sensor is on off conditions, maybe because of the sensor is broken or the communication system has been lost. And the yellow one was gaps. So it has significant gaps of information that it was deemed the data was deemed not good enough to be used for the EEWS system. Yeah, let's move on from the Indonesian EEWS system to the LRT seismic detection alarm system. This is simply an on-site EEWS warning that we put on the LRT system. So this is just an update of what we have done. Now it's already completed 100%, and we use pALERT sensor, pALERT Plus. We put it on 4 different stations, which encompasses the whole LRT system. Since it was small, unlike the LRT system and MRT system in Taiwan, which is already complicated, we put it on the west, north, south, and the east section of the LRT, our LRT system. So how does the system work? The system's, the seismic sensor, the pALERT, will detect the seismic activity mainly through PGA. And then the sensors record the seismic activity. It will send the data through the communication devices near it, because we put it not on the station itself, but on the, like a control panel room. So they have SCADA and they have the means to transfer the informations from the sensors to their main HQ. We transfer those data to PX01, the normal PX01, not the cube, and their SCADA system will transfer it to the center through their communication system. This is the PX01 that we uses on the projects. Also, it will gives also the trigger warning via hot wire cable. There have been some changes from the last time. I said everything will go through Modbus. Now we are doing the trigger warning via hot wire in case the Modbus communication broke. So this is also connected to the SCADA system, and it will give warning as soon as possible when the PX01 gives warning. Yeah, so this is the LRT topology. It will give earthquake early warning with 2 of 3 triggers to prevent false alarm. This is also changed from the last time I talked about, because the last time it was decided it was going to be 3 out of 3. Now it's 2 out of 3. And because it was, the installation is deemed reliable enough to do 2 out of 3. And then it will connect it to their own SCADA system through the SCADA RTU and their signaling system to trigger response if the earthquake that passed past the agreed threshold happened. For example, there's a threshold for the medium earthquake and the high earthquake. For both of the earthquake, currently the LRT system decided to just slow down the train and not stop the train, because they do not have like the necessary capability to actually stop the train and then evacuate the people. So they decided just for both of them, they will slow down the train and then they will stop in the nearest station and then they will evacuate the people. Okay, this is just the latest topology of the LRT seismic detection alarm system. So this is the drawings that we gave them. As you can see that usually we use 3 sensors per stations, including in the depot. We connect it to the switch, and the switch will connect everybody, including the PX01 and the WISE from ICP does. This is the PX01, and this is how the power was distributed. This is the hardwire that I'm talking about. So this is the PX01. The PX01 will trigger either it was a medium-sized earthquake or a large-sized earthquake. So this will give trigger to the SCADA, and then the SCADA will give information to the central control system. And this is the one that, and the control system, central control system is the one that will decide it if this warning is correct, and does they need to slow down the train or not. Yeah, I think that's it. So this is the latest Instagram post from our main contractor, which is Adikarya. This is the SDAS, they called it the Seismic Detection Alarm System that will detect the earthquake that will be affecting the LRT in Jabodetabek. So this is our installed equipment. This is in Harjamukti, and this is in Cawang. And this, as you can see, is the central control system of the LRT in Bekasi. This is the monitoring system of the SDAS. So it will tell you if any sensors is in trouble, is in off conditions, or even if the power was having some trouble, it will tell you. And it will also tell you from the Modbus that was sent from the Modbus communication can also tell you the intensity of each earthquake and the last earthquake that was sent from the PX01. So this is the 4 stations that we installed the sensors in. This is just the waveform of the successful event trigger. This is the real event, by the way. Location of in the Harjamukti LRT stations. So the earthquake happens near it in Sukabumi with a magnitude of 4.6 Richter scale, which was detected by the sensor installed at Harjamukti on the 14th of December in 2023. Fortunately or unfortunately, I don't know, it didn't trigger to slow the train. So this is not high enough intensity to trigger any of the restriction that was put on by the SDAS system. But it was recorded and it gives enough information for them to not panic and continue with their usual activity. This is the displacement. This is the data from another sensor, which is also in Harjamukti. Okay, so let's move on to the third part of the presentation, which is the BPI blasting monitoring and on-site EEWS project. Yeah, so early in 2024, Mindotama ships a package of 3 sensors and 1 PX01 cube to a mining company in Lahat in south of Sumatra. And this is weird because this is the first time that we succeeded to sell a set into a mining company. So first off, they wanted to use it for blasting monitoring only, but when we present our presentation to them, we managed to make them realize that the EEWS is also important. So they decided that they will purchase 3 and make an on-site EEWS warning for their own factory. So how does it work? This is also the first time that we use fiber optic as our means of communication. As you can see, this is the usual 3 sensors and 1 cube formation that we use. This is a cloud router switch and a gigabit media converter. So this is we have an SFP module embedded in the gigabit media converter. So we should use the usual Ethernet cable, and then the Ethernet cable will be plugged in the SFP module, and the SFP module will be plugged in the gigabit converter. And this red one is the data cable that is a fiber optic 4-core data optic from the gigabit media converter connected to the cloud router switch, and then the cloud router switch will be connected through Ethernet cable to the cube as usual. So yeah, the BPI blasting monitoring, first off, it was used by the BPI to monitor their blasting to prove that their blasting is not above the threshold that has been accepted by them and the people around the area. That is also being used to prove that their blasting activity is not above the threshold that will create a lasting damage on the environment and also their own building, because they have some different division handling the building and different division handling the blasting. So also what I wanted to mention is that this is the potential for our market, which has been told again and again that regulation is very important, and also it will affect how the insurance company will pay out their insurance money. To the BPI, BPI needs to prove that they are not at fault when they are doing the blasting. If something happens to the building or if something happens to the environment, that their blasting activity is not above the intended threshold. So this is very important. This is a potential for us sellers of pALERTs and other intensity meter with maybe insurance company to create a set of rules and to be able to create a win-win solution, so they will be able to better prove their activity is safe enough through this equipment, to prove their activity is safe enough that they are not at fault, so the insurance company can pay them the insurance money. Also on. Sorry, I cannot explain it very clearly, but yeah, I think you guys got it. This is the Krakatau POSCO, which is one of the steel mill company in Indonesia, located in around Western Java. So this is also unique because we use 3 pALERT and 2 cubes. 1 cube was installed near the control system and one is installed in the security place. Then, oh yeah, the Krakatau POSCO actually doesn't need any additional software from Mindotama. They have their own software. They only uses the Sanlien's equipment, which is the PX01, and the sensor, which is the pALERT, to get the seismic information and then transfer it to their own system. They have their own shutdown, automatic shutdown. They have their own public address system. So our equipment will be used to transfer that information. And if there is a big enough earthquake that they need to evacuate, then they will use their own system to evacuate and shut down the necessary equipment. This is we move on to the last one, which is the dam project. So as per 2024, we have done 4 successful dam projects, which is Tugu and Lewi Kris Dam in West Java, Kerinci Dam in Jambi, and Ameroro Dam in Konawe, southeastern Sulawesi. Below is the topology from Tugu Dam. So Tugu Dam uses only 2 sensors and connected to the radio link communication system, and the radio link communication system will connect the 2 sensors to the cube, and the cube to the PC to monitor the condition of the cube and the sensors. This is Tugu and Ameroro Dam. We usually offer the dam to connect the data to BMKG, but only 2 accepted. It's Tugu and Ameroro, and they will provide seismic data to BMKG, and then after we are done with the INA EEWS project, they will also receive the regional EEWS when it was fully operational. This is the radio link drawings and also the drawings of the panel. One of the reasons that we use radio link is it was cheap and it is very easy to install. But the cons is that it will need a direct line of sight between each radio link. And also the other disadvantage that we haven't mentioned, that it was prone to lightning strike because it was a little bit higher. So if you wanted to use radio link, I think that is one of the problems that you need to address. This is the protections that we created, that we use for our installations. Because in Indonesia, unlike in here, there is a lot of vandalism that will happen, and there's a lot of stealings. So this is a very important part. A very important part of our projects. That is the safety and security system. This is the drawings of installation panel. For most of our projects, not only them actually, besides the Ameroro Dam, because as you can see, Ameroro Dam is a little bit special. It was an off-grid sensor. It was installed as if it was a broadband sensor. So the panel we installed is much bigger than the default panel. And because it was pretty safe, there are a lot of security in the area, and it is actually a recreational area. A lot of people visits, but there's a lot of security. So we really don't need any cage. As you can see, this is the inside of the big panel. This is the batteries. This is the cabling. This is the e-home stabilizers, and this is the sensors. As you can see, this is we created a big peer table, and this is to keep the roach away. This is the owner also tell us to build the solar system. As you can see, this is the solar panel, and it's connected to the battery inside here. Okay, the last one is the last part is the threats to the solution and our answers to it. In Indonesia, there is some problems that needs to be addressed, which is the user or owner needs to be wary against. One is the lightning strikes. That, as I say earlier, in the dam there is a lot of lightning strikes, and if you don't have a good grounding system, it will destroy your equipments, or even worse, the sensor itself. I think maybe I already sent 2 back to Sanlien because of the lightning strikes, and we are trying to fix if we fix this with our owner, with the owner of the system. So the second one was vandalism or thievery. It's very rare in most countries, but in Indonesia, in open field, it's very dangerous if you don't pay attention to the security. And the third one was unstable current in central control power supply. It happens if installed in a remote area, like a broadband system. Maybe if you install it far away from the central control system that they doesn't have a good electricity, it's also a problem because it will cause damage to either your equipment or your batteries. This is also an uncommon threats, such as the unauthorized opening of pALERT case. In this case, it's on Kerinci. So the user, the owner, and their engineer open the case of pALERT. It is an unauthorized act by them, and when they close it back, they didn't pay attention to the cable. It got stuck, and it caused damage to the equipment. Thankfully, we managed to actually fix it, and there is not much problem when we install it next. But this is one of the problems that I think we all need to address, because this can happen to anyone. Maybe we need to put some terms in the contracts or avoid stickers of our own. I don't know. But this certainly things that needs to be addressed. So this is some of our proposed solutions. One is have a good grounding system, of course, so we can connect it to our field equipment. And it has to be noted that in our experience, if bad grounding systems are connected to our system, instead of decreasing the risk, it will instead increase the risk of the lightning strikes that give damage to our equipment. So the second one was put on the seismic sensor panel on a safe area that could be monitored by the security guard in charge of the place, but also, if possible, with as little noise as possible. So the second one was us as the seller giving feedback to the owner on the installation places, not only thinking about the data quality, but also the safety of the equipments. The third one was additional stuff like stabilizers, UPS, MCB, surge protector, terminal arrestor, and line arrestor. So currently, as per 2024, we always included a good quality MCB and terminal arrestor in our proposal to the owner. So to minimize costs, we hope that they have stabilizer or UPS inside the central control building. Because if not, then the cost will blow up, especially if we have to do the whole grounding system by ourselves. So trainings after installation is also important. So after 2022, we also always did trainings before we go and left a place. So it's our standard to do that. And some of the material of the trainings are, of course, product knowledge, because mostly it's a Sanlien product. So we are trying to explain what we install, how it works, and also additional products that they can use in their own conditions. The second one, of course, is the explanation on Richter scales and intensity meters. MMI, the Mercalli Modified Intensity. So a lot of people in Indonesia doesn't understand what's the difference between Richter scale and the intensity, which are used for the intensity meter system. So we have to explain on what is the difference between Richter scale and intensity that is used in intensity meter. And the third one was how to monitor and download the log file. The fourth one was what data output that we provide to their system. And the last one was simple troubleshooting and also warnings to them on what to do and what not to do with their equipments that we provided. Okay, that's the last of my presentation. Thank you very much.
The vibration standard used for the mining monitoring system.
I think it's the Indonesian national standard.
International. Okay.
No. I mean Indonesian national standard, not the international. The SNE.
Thank you. My name is Anand from Thailand.
Good.
How you do the grounding system for the dam project?
Actually, we do not do the grounding system for the dam projects. The one that do the grounding system was the dam owner itself, themselves. But if you ask us about how to do grounding system, usually we only use this like lightning rod and put a rod on some rods on the ground to redirect the lightnings. So it's like
How deep of your cow rod?
Sorry?
How deep?
Of
the cow rod?
2 meters. Oh, it's around 2 meters. Thank you, Mr. Budi.
Enough?
Yeah, I think in our experience in installing Accelerographs, it's enough, yeah. And also we have to search for a ground that have resistance less than 1 ohm. So yeah, if we found that and we can install a rod in 2 meters deep, yes, it's enough.
Never damage happen or not?
Of course, yeah. Sometimes the damage still happens, but mostly it's enough. In the dam, there's a lot of damage happening because we not in control of the equipment, and the resistance I think is above 2.7. So there's still damage that happens in the field. Okay. Thank you.
Anyone else? If not, thank you, Galvin. Oh.
Yeah, not a question, but a suggestion.
Yes.
We also experience a lot of issues on lightning strikes and surges, also electrical surges. So yes, we have grounding, we have circuit breaker panels, we have surge protectors. But one of the devices that I install is a time delay switch. So when there's a power, usually surges occur when there's a power failure and then when the power comes back, the power is usually very high. So installing a time delay switch provides you with a delay before the devices are turned on, and that saves a lot. So you may want to add that, which we have been doing for most of all our installations.
Time delay switch. Okay, thank you very much, Mr. Charlie.
Well, good afternoon to everyone. Thank you very much, Sanlien. Thank you very much, Jim, Reid, everyone, for inviting me today to give this presentation. I am very excited about this project that we're having currently. We have worked with the Sanlien products on other developments and other system integrations, mostly in dams and in a few other projects, but this is our biggest and current project that we're working currently on. And I just want to give you a brief look into it. So, well, the presentation is about our earthquake early warning system. So, Base Sísmica is a company, my company. I founded in 2018. So around 7 years ago, we started that system integrators. We're also a hardware company. So we do represent GROP systems in Mexico and Central America. And we have currently acquired a few other representations on other hardware stuff. So as system integrators, we normally worked for, as projects or mostly for academia, for the Seismological Service, for a few other entities in Mexico. So we thought that we needed to move forward with, something more on a recurrent revenue as businessmen and people know that we need. So we started working with a company called Seismic AI, which is an Israeli-based company, software company. And we went through a joint venture together in 2023, end of 2023, to develop an earthquake early warning system. So, for instance, this is a top quality and private seismic network that we're developing together with our own resource investment. So that's why we are very proud of it. This is just a small overview of what it is. The seismic network, which is made of Accelerographs, is based in the whole, the coast of Pacific of Mexico. And it is made from 50 stations, 50 regional stations. And we happen to win a project with a bank with 250 branches. So we are serving them, but not only serving them, we installed a seismic station in each of those branches. So that gives us a wider and a bigger network. Right now we count with over 300 stations that we can work with. So, all right. Well, this was a very challenging part, and well, very clever that you put us together with the other EEW system in Indonesia, because yes, one of the main issues, not just to perform a layout of what could be a good seismic network, right, in terms of localization of earthquakes and stuff, but you tend to find these problems as vandalism or as communication, things like that, that we go through mostly in Latin America. We are still, developing that. But this was the first proposal of the seismic network. Initially, we wanted to install only 40 stations. It is important to say, though, that the system works on, well, in order for the system to be effective, since it is an algorithm that works with AI, and it is a cloud-based system, it is based on a specific layout of a seismic station, which corresponds of 4 different stations calculates the back azimuth, and it's very efficient to locate earthquakes that are like very far offshore, not just inland. So in order to do that, we had to find the correct space, the correct layout for this seismic network. And this was our first approach to it, like 40 stations located in all these areas, and that would perfectly fit our model. But then we found out that we could not go into many of those places because of, you know, narco, basically. We cannot move around many of these places because it is very insecure. And there is no communication, there is nothing in between. So we had to find a way in order to install those stations because, again, it is a private network. We're not working with the government, we're working by ourselves. So our following iteration, which basically was by working with the collaboration with the civil protection agencies, mostly in the south of Mexico, Guerrero, and all these states here. So we made collaborations with them for their facilities to be used and to secure our stations. Then we also had power to use for our seismic stations, and we also were able to use sometimes their data, or we provided a cellular model in order to communicate the systems. And we were finally able to locate all of the circles that you can see here are the regional stations. The ones that you see in red are the ones that are already deployed. And the ones seen, I'm sorry, backwards. The ones in blue are the ones that are already deployed, and the red ones are the ones that we still haven't deployed, but we're working on it. And all of the green dots and red dots are the very local stations, which are the ones that are inside each of the bank branches. Now, this local network is formed by 250 local stations and 6 regional network single stations that we deployed into, the area of the banks. Now, this is how it currently is performing. The goal was to have at least 40 stations, 40 seismic stations already deployed by the end of 2024. But basically, and this is something that we were just talking about, communication is an issue in Mexico, like good enough performing communication, low latency. Because for earthquake early warning systems, we definitely need a low latency communication system. So we are working with cellular modems, we're working with satellite communication, but still our latency was really high. So we wanted to lower it down, and we iterated a lot. We could finally get to, right now we are, I think, 0.5 seconds or something like that, which is actually really good for our system. 20 operative stations in February. Actually, right now we have 5 more, so we have 25. And as I was mentioning before, for this system to be effective, the base of the algorithm is to have array seismology. So it means 4 stations located in like very specific areas. We couldn't put array stations, so we only used single stations for this, but the algorithm is helping us, and it had to be improved. So with the single stations, we could form arrays in order to locate earthquakes very far away, mostly offshore. Again, offshore earthquakes are our main problem in Mexico, which is like, for example, this case. Normally, all the blue dots is like, we have more earthquakes or more big earthquakes, above 4 or 5 in that area. So we want to be able to trigger alerts or to provide information with I don't know, even a few milliseconds to the offshore and to onshore on the coast, not only to Mexico City, because one of the things is that the national system currently only serves Mexico City, Mexico State, the states that are, you know, here. So that's why we have good enough time in order to, you know, to evacuate or whatever. But mostly these states are not well served because of the time that they have in order to react. So this was our network status in June 2024. This was up to September 2024 as well. So as you could see, we were already able to locate a few earthquakes with only maybe 11 or 12 stations. So it was a really good performance, even though we had very few stations back then. So that is a part of the layout of the network. And right now, we have 25 installed stations. They are all FBA, force balance accelerographs, in all of the regional stations. The coverage is 5 states: Jalisco, Michoacán, all of the Pacific coast, basically. We are using LTE communications with Celeron model, BPN sent to Seismic AI, which is the algorithm that is running constantly, and the BPN tool to proper management to have a proper management of the seismic stations. We have also some cloud solutions, the GROUP tunnel, RMS with Teltonika. We are using Teltonika for the cellular modems, so we can, you know, monitor the SHO of the stations remotely. And we have a remote reset. For instance, one of the challenges that we faced last year is that there was a big hurricane in one of the cities that we had, well, in one of the states that we have most of our stations at, and they were flooded. So we couldn't get to them, and we had to find a way in order to, you know, remotely reset them. So we added this as of that. That was maybe July, August, or something like that. And the Network Operations Center, which is a NOC. We have a NOC that is constantly telling us if the communication is on or off. Actually, this is another big issue as well, because even when the communication is very constant, in some of the states, again, and this is true, they are like narco zones, so they ban the signal, and we lose the stations for a few minutes, and then they come back. So for our system, that is really bad, so we had to figure it out somehow. So we had to install more stations. But this happens in Mexico. So how are they formed? So we're using Fortimus. Fortimus is the FBA sensor for from GRUP for all the regional stations. I'm going to go fast on this. And the communication system is, as I mentioned. So we have an internet connection between, since the algorithm runs in the cloud, for it to be more efficient and low latency. We are doing, each of the stations have a modem, a Teltonika modem, and they are communicating all at once to, you know, the internet. All the information is being sent to the Seismic AI server in EEWS. It's being, you know, processed there, and it sends back to each of our POIs, which we call points of interest. Every point of interest is the site that we're monitoring and alerting. And each of the local stations is a POI, right? So we had a lot of discussions about this on only using, in this case, Sanlien as an actuator, or to actually use it as a second or an extra piece of information, which is the sensor part, and which would trigger the alert unit, either Seismic AI or because, you know, the pALERTs can do it themselves. So what we decided to do is to use the pALERTs as another part of the information, as another station. As I mentioned, that's why we have 260 different stations there, all of them transmitting data at the same time through the same way. And we were able to incorporate, it's a cabinet, and this cabinet has the ability to, through a board and through the MQTT language, communicate when it should be triggered or not. And it all depends, like the decision maker, in this case is the Seismic AI algorithm, calculating the intensity in that specific site, and the cabinet or the alert system receives the instruction, and then it gets triggered. Now, the software that we use in order to check our waveforms, to check on our data, we need to, all the data has to be very reliable for us to be able to make the decisions and for the algorithm to process. So we're using, for sure, the in-house software for the GRELP sensors, which is Discovery. We're also using SeedLink, a SeedLink server, because we send this information as well from all the pALERTs to the cloud, and a VPN data transmission via SeedLink protocol. This is part of the work that had been done. This is from the regional stations. So one of the things is that, as I mentioned before, it was very difficult to locate land. Like, if you're in a government, if you're in a security institution, if you don't work on that, it is very hard for people to just give you a piece of land in order to install a station, right? So it had been my job, thank you, to move around Mexico and to find this. We are using currently a few schools, all right? So we educate as well well, the people around or the people that are in these locations that have trouble with earthquakes, so we're using that. We're also using a few stations from the civil protection agencies of the states. So again, this has given us a lot of security for the stations, meaning that we haven't had any vandalism so far. If you provide something to the people that is, helping you manage one of these stations, they're just like very, grateful to have, so they really take care of these stations, and I'm very lucky and happy that it has been like that. But we also had to figure it out how to make a station small enough and efficient enough to, to be installed in just 1.1 meter space, right? So, and we needed to have communication, we needed to put the sensor inside, we needed to communicate everything from the inside of the station. So we were able to, just design a very small box, as you can see here, which also has a solar panel. We use 2 batteries inside, and all of this, well, as you can see, we have the modem, we have the control system, we have the grounding system there. Everything is in place of a very, very small box, which we call a portable station, right? So even if we need to change it from location whenever we need, it's just a very easy task to do. And again, we are monitoring them remotely by the internet connection. So all of this, this is some cloud tools that we use to monitor the behavior or the health of the stations, if they're sending data, the latency, everything we can monitor from remote, and we have a group that is constantly checking on this information. We also use RMS in order to monitor communication. And again, we've been able to, at the beginning, the very first 3-4 months, our latency was above 5 seconds. Right now, we were able to drop it down to 0.2 seconds, I think it was the least, but average 0.5. So that is a very good latency that we're getting, only using cellular modems, and it has worked actually very well. Teltonica Cloud Solution to remote manage system, review, to review each of the stations and the parameters of each one. And this is a cloud tool that we use in order to monitor. These are all for the regional stations, but we also have one for all of the local stations. And well, this was another big task to do. So when I don't know, you don't really get to know that there's a lot of information to be incorporated into just one single database that needs to provide everything for you to understand if everything is working properly, from the location, from the communication, from the data stream, from the acceleration, from everything needs to be monitored constantly. So you need to have a group of people who is constantly checking and building a database in order to have a record of all this information and get to know when a failure starts or happens. So it's a huge, huge, huge work to do. We could have done something different, but anyway. So these are our local stations. Again, they are formed in a very small cabinet. We have a pALERT Plus, again, adding up to the data stream of the seismic data. We have a cellular model. We decided to do this, and this is important to mention, the project with these bank branches, and we have a couple of more projects for around 20 different sites for 2 other customers. We decided to do this on a SaaS model. Why? Because we keep control of the communication, right? If we don't have the communication, if you don't have that data stream, then we have nothing. We need to keep control on that. So it was a very challenging part for some of the branches, for example, because they were underground or they didn't have, a point in which the communication was good enough. And in some of them, because it is a bank, there is a lot of security throughout, the communication by cellular. So we had to go through a lot to get the proper permissions in order to do this. We were able to do it. But in most of the cases that we have, offered this, this is one of the issues that we mainly find, that they don't want an external communication system being input there. But yeah, well, that is one of the things that we're going through right now. So the hardware is a sensor. We have a control board. This was designed and incorporated in Mexico. We are building this in Mexico. We have a radio board. We have a modem, a battery bank, and a charge controller. So all of this into this cabinet, which is, helping powering the whole system. And, well, the resources that we could do this, we were a 5-people company at the end of 2023. Right now, we're a 20-people company as of this project, because definitely field work, management, administration, databasing, communication, and all the et ceteras. Of course, we needed more, but we were able to do this with a very few, with a very small crew that was working for this. And we made some alliances, really good alliances with institutions with civil protection, as Jalisco, Guerrero, Baja California, and Morelos. Currently, we're working actually not only on the alliance for them to help us, have a station there, but to also be, for the regulation to be put in place in those states regarding earthquake early warning. Cloud solutions, communications, obviously seismic AI. Most of the problems that we found, we were able to, fix as they came. We never knew that they were coming, but we were able to fix them, most of them. And we have a monitoring system platform that was developed last year to monitor the whole system 24/7. So these are some of the pictures when they were beginning installing of the station. So it was like a tough job. Thousands of kilometers being driven by them. So again, these are the stations. They are very, again, small boxes. We try to be as efficient as we can. We have the sensor inside. We have a battery, sometimes 2 batteries and 2 solar panels, depends if we get to have some power or not from the local station. Well, yeah, basically this is how the station is working. We make functionality tests constantly, every day, at least twice or 3 times a day. So we get to know if everything is working properly. And we have been able to get some really, really nice earthquakes, because the only way you can test this is by having earthquakes. Well, it's bad, but it's true. So some of the recent assessments that we've done to the network, and this was just maybe 3-4 months ago. Again, we had a lot of issues with the communication, where we were finally able to get to a point in which everything is working properly. Everything is, constantly sending data. And these are a few of the events that we have been able to capture. When it all depends on how many stations triggers or gets the information of the earthquake that we put it into our report. And just for instance, we have been able to match or almost match catalog events, meaning that the seismological service says, I don't know, the location is exactly in this place and the magnitude is XYZ. We were able, the last one, we were only 20 kilometers away from the catalog one, which was really nice. This was a very recent one. I think it was 3 weeks ago or something. This was in Guerrero. This is the system. This is our monitoring system. This is what we see when, at the office, at the monitoring system. And the location or the triggering came from these 3 stations that we have here. Again, the catalog location was exactly here, and our location was only 20 kilometers away. So that was very, very, very close. And the magnitude was actually 0.1 or something difference. So it was very efficient back then. And we recently, I added this one because we are also developing 2 more platforms. One is our app. It's a user's app that is being under construction. And there was an earthquake while I was flying here. So when I opened my phone, I could see the messaging and everything, and that came from that event, which was on Friday. I think it was Friday. And this is the report that we were able to get. We have a group of seismologists working with these reports and retrieving the data. This is from the app that we are developing. As you can see, the app didn't get the magnitude of it, but it did get the location of the earthquake. So it was a 5.5 earthquake. None of the local systems triggered besides ours. And this is the monitoring system that we're using. This is another nice, really nice example. This is a building in which we have 3 pALERTs monitoring the structural health monitoring, because this is our next step. And in this report, this is a report that you can get only 5 seconds after the event. The report actually got the correct information. The building experienced weak motion, and these are traces gotten by one of the pALERTs installed in this building. So we are not only using the pALERT in order to get some more data for the stations, but we are also using them as a structural health monitoring project. And if you want to see any of them, I have a bunch of them. I can even show you the API and the dashboard that we're using for this project. We are also doing, since we're a group of geophysicists and seismologists and a lot of academia in the company, so we're also doing with this information a lot of other work. So it is, the guys have been working on analysis that can be done with acceleration for regional operation stations. We are trying to get into mining, basically, geothermal, with this information. Some generation of regional maps of peak acceleration or macro hazard maps, location of focal mechanisms, the location of some events above magnitude of 6, sorry. And later, long term, our network were to be converted to hybrid. So we are planning to install not only accelerographs or accelerometers, but also broadband stations. And with this, we can also have other types of products related to, the hazard in the area. And well, finally, the next steps is that with this project, with this big project, we are going to have a total of 660 stations, local stations. We are developing our Baja California network, 20 stations, regional stations in the whole state, to serve up to 400 sites for the government. So this is only for 2025, a lot of work, but we're very proud that we can develop this. So this is it. Thank you very much. Questions?
Your app for mobile app is open app or not?
Right now it's still under development, but we can. We're providing demo versions to test, but it's on a 70% development right now. But it actually worked very well during the last work week.
Thank you for the opportunity. May I ask, how do you reduce the latency in your system?
How do we reduce the latency? Well, we're working with a local communication provider. Well, first of all, the traveling of the data from the station and then to the cloud and then back to the stations or to the POIs took a lot of time. So we tried to use best locations for the information, and our carrier was able to adjust smaller latency on their end. So it is nothing that we did on our end. It was a teamwork that we developed with the carrier that we're working with, which, by the way, works not only with cellular, but they do satellite, they do fiber optics, all other types, and their modems are able to, or have that capability of adjust to any of them.
Thank you very much.
Welcome.
Any other questions? I have questions.
Yeah.
So number one question is, what is the positioning time for the earthquake early warning system in your network? The average positioning time.
The average positioning time, meaning
10 seconds, 5 seconds.
But it all depends on the location of the POI. But the fact that it is also using AI means that we have been able to reduce that time at the beginning. For example, and let me go back a little, if I can. So I will try to. Okay, so this is a small map. The national network has, stations all around the Pacific coast in order to serve the central states, which are like the biggest or maybe the most important, but we also have here a few. So from the catalog and having the stations that we have in the Pacific, we were able to reduce by 10 seconds what the national system could do just in Mexico City, right? If any of the earthquakes are located in this part of the coast or offshore, even 100 kilometers offshore, we are able to get accurately. And by processing the data with time, we had been able to reduce that by 10 seconds, which is a lot. Just in Mexico City. And for the states of Guerrero, for example, in this very specific area, we were able to give, for very close events, there's a blind zone, we cannot do anything about that. But for most of these cities inside here, we were able to get 20 seconds, 15 seconds.
And my second question is, can you run your private network in Mexico? Is it illegal or legal?
It is not legal or illegal. It is not regulated. But there are other companies that use some sort of accelerometers, mostly to serve Mexico City. But they are based mostly on the national network. So it is definitely something that you can do. It is not anything.
And my piece of advice for the developing app from our personal experience and the experience as a country. Usually, if you develop an app, either iOS or Android system, if your download user are more than 100,000 user, it will become a limit because the push message is 100,000. So for example, if you have 1 million user, that will be a difficult task.
Okay.
So in Japan and in Taiwan, which we both commercialize our earthquake early warning system, but we use radio protocol to push out our message. So for example, if there's an earthquake right now, your phone, if it's registered in Taiwan, like if you turn it on and it's connected to our carrier, we reserve a special bandwidth to push radio message into your phone and tell you, oh, the earthquake is incoming. Because there are 23 million people in Taiwan, and that is the only way to efficiently push out all the message.
Correct.
And then there are 9 antenna emergency stations in Taiwan because we split Taiwan into 9 grids. It's an island, so you basically cut like a cake, and so it's 9 sections. So just be careful when you develop an app because it can lead to a lot of delay. Because Sanlien used to have our own app. If you want the source code, I can think about to give it to you because it's not. We terminate the app already because of the mechanism of the pushing message system. It's not our problem. It's the whole network problem. So
No,
just be
thank you for
careful
that.
with that.
Actually, what we are using the app for right now is not for the public itself. We're not selling it. We're not using only the users that have the system integrated into,
Yes, that's for sure.
So that's how we're using it right now. We don't want to go like really far away with that.
It costs money to develop an app.
Yeah.
You want to get return somehow, some way. So just a piece of advice.
Thank
anyway,
you, Chen. Thank you for that.
Oh, Charlie.
I was expecting that question, Charlie. I was
Which-
just
well,
waiting for it.
Yeah, well,
I don't know what.
coming out from Jin's observation, it really is there really is a matter of looking at the delay issue in a holistic manner. So it's not, communications is one. And if you use satellite, forget it. Because there's already so many seconds of delay just because of the distance from the station to the satellite. That's one. Number two, fiber. And I'm not sure whether fiber is existing in all the locations. Radio is good. Number three, the app and the processing that goes with it. It also poses another delay. So which brings me to really looking at the whole setup on delay and on alerting system on its own. And maybe having processing near the sources of the sensors would also be good. I don't know. But then we have to, again, take a look at all these issues separately and holistically at the same time. Thank you.
Yes, and thank you for the feedback, because that's something that has gone through our local, internal discussions. Mostly latency is the main issue all the time. That's why we were able to, to locate some sort of, in a few places, the problems that we were getting and to correct them properly, but taking them as a piece, not to thinking about an overall issue, but a single matter issue of each of the stations. So that's how we were able to fix the problem very locally in each of the stations. And right now, I can definitely tell you by the stations that we have running, the latency is really, really short. And we have been able to trigger the alert systems on a very timely manner. So far, after a lot of iteration, it's properly working.
So good afternoon, ladies and gentlemen. My schedule is called the schedule when it's hora de peligro in Spanish. What does hora de peligro in Spanish means? Hora is the time when it's dangerous. And it seems that everybody's listening to me, which means that I am going to get your attention. So it's not going to be hora de peligro. Do we have a clicker? I'm sorry. I took a picture of our food. So why did I take a picture of our food? Who wants to take a wild guess? The before and after. Nobody? So number one, I wanted to find out what kind of fish it was. So there are two ways of finding out. Definitely, I asked the waitress what it was. Took her so long to find out. But then I also asked ChatGPT. So with ChatGPT, it answered it's either grouper or forgot. But then the answer was grouper. But it had another choice, which meant that ChatGPT may not be the perfect solution. I also asked what kind of vegetable that purple thing was. Oh, where's that? Yeah, somewhere there. It's purple radish. I thought it was ube or yam, purple yam. No, it was purple radish. So, but last but not the least, before my body turns into a disaster and I've gained weight, I wanted to ask how many calories I consumed. And ChatGPT told me how many calories it had before, how many calories it had after. So that's the kind of, has anybody tried taking a picture of their food and finding out the calories using ChatGPT or any AI agent? No one? So something that you learned today. Huh? So I will make sure, I will take a look at the pictures of your food later on, find out how many calories it is. Anyway, so what, I'm sorry? oh, I consumed 700 calories. So I thought, I asked ChatGPT to log my calories from now on because I have a goal to take. Let's see how it works. So when you find me 2 years from now, let's see. Okay, so how do I turn this on? So what's wrong with this video? How do you do it? Okay. Oh, there you go.
NDRRMC 135
Yeah, that one.
AM 27 Sep 21
No, the
Isang
other
magnitude
one.
5.7 Na Lindalang Naganap Salo Occidental Mindoro Cananong 112 AM. Aftershocks that damages Ayanasahan.
Okay. So what's wrong with this? This is a video, this is an actual video of an earthquake a few years back. But the issue here is that the alert was after the earthquake. And they just tell us to watch out for the next ones. The next video was supposed to be, it's another video, I think it's maybe from Sanlien, I'm not sure. But it just tells you that it's almost real time. As soon as the earthquake happened, and you get an alert, something similar to what was shown earlier, but it was on real time. Unlike the first video, wherein you had to wait for the aftershocks. So this is what's in the Philippines right now. So just imagine how many earthquakes we have. And there were major earthquakes. But then, what does the country need? We need a stronger seismic monitoring and mitigation strategies, not an afterthought, which is always what's happening. So we have several earthquake monitoring systems. So, for example, PHIVOLCS, the Philippine Volcanology and Seismology Institute. We have in Marikina, it's a city near Metro Manila. You have flood sirens. You have earthquake recording instruments. And then in Iloilo City, there's a system with 25 systems donated by Sanlien. But what's the issue here? These are all isolated systems. No integration whatsoever. Sad. It's there, but it's sad. Now, some more problems. SM is a huge company in the Philippines with so many malls. They have their own system, but it's only for their own use. It's not even tied up to a central system. You have Makati City, the foremost city in the Philippines, has, we just had a 400 million peso project on Internet of Things using LoRaWAN. But then, again, it's just for the whole of Makati City. Also, again, PHIVOLCS and other places which do not share the data. So, how do I see things moving forward? Unfortunately, the ERI or earthquake recording instruments that are installed in buildings are just for compliance purposes, just to make the building official happy. Somehow they comply. And what happens when there's an earthquake in a particular location? Each and every building has an alert. And then you have to submit a report. Before it used to be printed, I submitted a 500-page report once. I don't know whether they read it. Now they send it on discs. Now you can just email it. But it's still manually obtained. No actual integration. And then, how do we see things happening in the near future? It should be, again, with our capability of Sanlien, it should have real-time or even proactive alerts. We should be able to integrate all these things together. Again, you have, well, again, this is my pipe dream. So many systems all tied up together. And this is how I want it to be. An earthquake warning system that is proactive. Something that you can get on a smartphone that tells you a few seconds before it happens. Because we have the pALERT system. Issues are always, in the Philippines, is always on funding. But there are several institutions that can provide funding. ADB, the World Bank, NDRMMC, 2 or 3% of the allotted budget for each local government unit should be spent on disaster. The issue there is that when there's this fund, they just buy rubber boats or emergency generators. It's I'd say backward or so. No technology whatsoever is being talked about all the time. So what's next? How do we see it? Again, we have to start testing integration. We are trying to work with Makati because I am connected with the IoT network that we sold to Makati earlier. Then we have to start providing a national database so that we can secure funding. It can be a smart city funding. There's a funding from the United Nations. I don't know how well they are going to stand with the new president. Somewhere out there is cutting the funding, but then let's see how it works. Wait, there's something that I missed here. So, anyway, we missed 1 or 2 slides. Anyway, going back, how do I tie up AI with what we've seen, with ChatGPT, with all this? I would say that in the next 2 years, we should have easily an integrated system by just feeding all this data to our AI agents. And the AI agents themselves would be able to provide us with the alerts already. That's how I see this happening in 1 or 2 years. It's going to happen very, very quickly. We do not even need to do coding. We do not even need to come up with an app. We can easily tell the AI solution that this is the kind of latency, so design the system. I would believe it will happen very, very soon. So the secret is we, technology people, should watch out for all these new things happening and be able to integrate this with our current solutions. And that is the end of my presentation. Any questions? Jen should be able to ask me another question. ChatGPT, you don't rely on ChatGPT all the time. You have to know when it is a bit stupid. Sometimes, and it doesn't know how to draw well. It provides you with bad drawings. But then you should be intelligent enough to use ChatGPT. If you're a slave to ChatGPT, forget it.
Any questions? No questions?
No questions. Oh, anyway.
No, I mean, Mauro.
Yeah, sure.
Mine is not exactly a question. The data sharing between organizations is something that should be pursued as much as possible. Yeah. This is not so good for business because we will sell less instruments, but it's something that should be encouraged, in my opinion, to defend people. The question is, but it's a question I'd ask to everybody here. Maybe we can think about and maybe bring a solution in the next occasion. How convince people and organization and private organization who has a lot of seismographs use it privately to share the data? This is an issue in Italy, for example, because we have, as I exposed this morning, hundreds and hundreds of seismographs and accelerographs privately used by oil and gas company, and they never share data. They are jealous of data because they maybe have secrets of something, no? Or what's happening on the seismic fields. So how we can convince? It's a question I'm raising, and then we can. I think we cannot ask to ChatGPT the answer.
So, well, I would say that there should always be a push from us to be above our own interests, because I think from there people will see, hey, these guys are not making money out of it. It's really for the good of everybody. So, and in my case, I know it's not going to be good for me because I will sell less earthquake recording instruments. But then, when people are more aware, and with Sanlien being able to design new equipment and new solutions, there will always be new ways to make money, not just ERI. Right, Jim?
I have a more practical question. Since you're involved in the Makati City IoT network, I'm just curious, what kind of information, what kind of data do you actually get from the Makati City in terms of the IoT network? Like, what do you feed back to your system? Like, what kind of sensor do you guys help them to implement, or data you gather from it?
Okay, so we are right now measuring all the power consumption of all the Makati City public buildings. That's number one. Then from there, you know, is somebody doing pilferage? Then you get some kind of measurement. You get some form of data analytics. Also for water, some public schools that are shut down is consuming so much water. Maybe there are residents nearby who's getting the water from the public school. We just recently installed, instruments to measure the power consumption of street lights in order for us to find out if a street light is busted or not. We installed it, we found out some street lights that are busted. We also found out that there are a lot of taps, illegal taps on the street lights, and that makes the illegal settlers near the street lights happy at night. So getting all this data will provide the city with lots of information. 30%, going back to street lights, 30% of the power consumption of the whole city is on street lights. So little things that mean a lot. Yes, I know LoRaWAN is being used, but LoRaWAN, again, is not the be-all and end-all of all IoT, as I said earlier. So just, again, going back, just getting the data for now will provide you with a lot of insights later. Yes, please.
Thank you. We would need to have more like private networks, just as a comment as well. In order to adjust our model, we needed to get a velocity model local velocity model. And the most recent one was developed by the Seismological Service of the country, and that is non-public. Even if it is governmental, and we are basically citizens paying for that, we cannot get it. So it was a matter of us doing the work. So if even what needs or has to be public isn't public, and I do get your idea on people need to be informed, but how do we get all that information? So not even from the government. Mining is a private company, and they can always say, I'm not sharing. But not even governments are doing it properly. So that is an issue that I see with the whole ChatGPT and getting information.
Well, I'd say that we do it little by little. I think people are going to get used to more data. I think it's inevitable. More so with AI available, it is inevitable. I hope so. It's a pipe dream. Anyway, thank you guys. Oh, another question?
Maybe you can suggest Sir Jean Lim about the presentation he made earlier about the temperature humidity. They are working on the temperature humidity, and we have success in Philippines. Yeah, you can share with him suggestions about temperature and humidity. Our projects.
Oh yeah, heat index is becoming an issue right now, also in the Philippines. So, well, we have temperature and humidity sensors right now, but I think there really is a push for heat index sensors being provided strategically.
I mean, that's the key. But of course, when this is actually all related to the topic of smart city. So when Jocelyn was talking about you're building your own network, and then you have your own sensor network that is developed by, commissioned by Makati City. But in every country is different. For example, in Japan, you are not allowed to have private network. All the data, you have to give it to the government. In Taiwan as well. So in Taiwan, because a lot of laws in Taiwan, we actually copy Japanese law because we colonized by Japan before. So in Taiwan and Japan, we both have a law called the weather law. So if you are not, if you don't have a license, you are not allowed to forecast weather or not even disclose earthquake information, even waveform. So this is something very, very different from, I mean, region by region is very, very different. For example, we do a lot of geotechnical monitoring. So basically, in Taiwan, we know where the landslide will happen, and we know where the soil liquefaction will happen. But as a company, we cannot release those data because it will affect real estate price. So a lot of time, we are not allowed to share. And because the land developer will not be happy. An insurance company will not be happy because there are 36 active fault lines in Taiwan. So according to our regulation, you cannot build any buildings 20 kilometers away from the fault line, but that's impossible. We live in a tiny island, you know. So this is releasing information is always a very, very critical part of our job. Like what to share, what not to share. I mean, of course, in some country there are laws, some country they are not. But I mean, I'll give you a little example before we close this section. And I think it is related to communication as well. So as a company, Sanlien, we start doing this NB-IoT and wireless network because of one incident. It was a beautiful mistake. And that's before I became the chairman of Sanlien. There's a company in the world called Foxconn. I don't know if you heard of it. Foxconn is the world's largest electronic OEM company. They make iPhone, and they make a lot of devices. So the boss is called Terry Guo. Terry, he is a visionary as well. So back in 2016, when LoRa was first introduced to the market, his dream is to, I mean, of course, he has an electronic company already, but he wants to ask for recurring revenue. So he actually acquired a telecom company in Taiwan, which is called GT4G. It's a very strange name. The company is called GT4G. So and that time, it was an interesting time because Terry, Foxconn actually acquired Sharp. I don't know if you know the company Sharp. It used to be a Japanese giant for making electronic. And there are a few reasons he acquired Sharp. First, he needs to get a panel technology. The panel technology used for your iPhone. because at that time, if you want to get OLED, you can only get it from Samsung. So they don't want this become a threat to their business, also including Apple. So that's the reason they decided to acquire Sharp. Another reason he decided to buy Sharp was because he needs the market share of home appliance. And then, okay, now it gets getting kind of interesting. You have home appliance and you have telecom company. What is he thinking? So at 2016, Foxconn came to Sanlien. And then he said, oh, Jim, now we have a telecom company and we also have Sharp. Because Sharp produces a lot of microwave, a lot of refrigerator, and all kind of home appliances you imagine. So Terry's idea was to install LoRa chip in every single home appliance that made by Sharp. So the telecom company he owned in Taiwan, GT4G, back then have 800 LoRaWAN stations. So Chen and I, we've spent so much effort on trying to integrate this LoRaWAN back then. So the idea was prevention. So they will every electron home appliance will send data back to the Foxconns and Sharp, say, oh, through LoRa, saying, oh, your refrigerator, your microwave is about to break. Time to get a new one. So that was his idea back then. Great idea, but he failed. Why? Because LoRa didn't work at that time. It was mature, but the communication distance was bad. And second of all, it was not paid by the user. It's paid by the telecom company. So at that time they said, oh, this project failed. So so starting from the beginning, this business model is not working because nobody is paying the bill. If you got so much data, so what? Nobody is paying the money. So that's the reason since 2000, the project terminated before 2018. Sanlien, we still have like a couple hundred LoRa chips inside the house in our inventory. I try to discard them every single year, put into my bad debt, you know. I cannot put it all at once. I need to do it year by year, you know. I spent millions and millions of dollars on buying those equipment. But at the end of the day, that model failed. And so the whole project terminated around 2018. And 2019 was the time the government started introducing NB-IoT. And because it has the idea of SIM card, so you can actually get money from the end user. So that was the reason why LoRaWAN or LoRa, I mean LoRa still exists, but LoRaWAN in Taiwan has a whole network fail. That was the story back in 2016. And I learned my lesson in a hard way. And second of all, I hate setting up gateway. Because I was in the rain and then like setting up a gateway, like, oh, like a little dumbass, and then like try to position where the best light up signal. So that was the reason we switched to NB-IoT. I hope this little story will give you some insight, but that was a story from almost 10 years ago. Anyway, anything else to add?
Yeah, I want to add to that. So I'm just thinking aloud. So I think heat index is very important. And heat index, I think, will democratize sharing of data because it is not earthquake, which means that heat index always depends on it's not permanently hot in a particular place. It changes depending on the weather. So maybe start with heat index as a way for you to have information for everybody via the local government units, by the cities or by the towns, and then start exchanging information. Then maybe we have a whole heat index database for the whole country. I don't know whether that will work, but then I'm just maybe posing the question or also asking if that will at all be possible. What do you think, Chen?
To counter that question, so when we as a company we are studying the heat index problem. So in Taiwan, the whole island is about 400 kilometers long, and then Taipei. Let's just say Taipei City itself. Taipei City. I mean, even though we're in Taichung right now, but I'm more familiar with Taipei. Taipei is about 117 kilometers square as an area. And in the zoning system in Taipei is a bit strange. So every 10 to 20 kilometers square will be one zone. So that's the reason you will hear about Da'an district, Zhongzhen district, all kind of district. But there are two things when I was discussing with the Ministry of Labor or the weather company in Taiwan. So now they are trying to use, the first approach is using satellite to see the heat wave of the land. And then they use a software simulation, AI simulation, to simulate, which area will have the chance of heat index. So in that case, you don't need sensor. And the second approach is they make law and then ask the construction company. For example, there's a construction site right there. You ask them to, like a geotechnical monitoring, you have a little sensor put it up in your construction site. You basically self-warn yourself. But the law has not been settled down yet, so we don't know. But the reason that it was on part of our roadmap was we see this coming. Because I mean, some people, they don't believe in global warming, but the Earth is getting warmer and warmer, that's for sure. So that's from the data we got 20 years ago. So that's the reason we decided to go into this path. But we don't know yet. I'll let you know in the next 2 years. Hopefully.
Yeah, we'll soon find out. It might be another business for you guys.
Yeah, maybe,
and for us to sell.
Yeah. Thank you.
Thank you, guys.
Thank you.
And today I will be discussing about Sanlien.wireless data logger and cloud platform. Let's get started. So here is a quick overview of today's presentation. First, I will begin with brief introduction to IoT, and then I will be discussing about Sanlien's geotechnical products, and then I will be discussing about cloud platform, and then I will end with some case studies for us to discuss. So let's begin. And so currently, countries with LTE-M and NB-IoT covers all continents all over the world. Currently, according to GSMA, per September 2024, there are total number of 252 commercial mobile IoT networks. And this includes 137 NB-IoT networks and 115 LTE-M networks. And this widespread adoption of these technologies demonstrates their reliability and improving importance in IoT applications. And also here, according to GSMA, there are some countries with their providers shown in the screen behind me. For example, in Taiwan, we have Chonghua, FET, Taiwan Mobile. And in Singapore, there are Singtel, StarHub, and M1. And in Thailand, there are AIS and True Corporation. And for example, in Australia and New Zealand, there is Vodafone, Spark, Telstra, and Optus. And in Europe, for example, in Germany, there are Just Telecom and Vodafone. While in Sweden, there are Telia and Tele2. And in the United States, there are multiple IoT providers, for example, AT&T, T-Mobile, Verizon, and US Cellular. And one of our partners here use Etisalat as their provider in UAE. And for more complete list of countries and their providers, please refer to the official GSMA website. And in this occasion, I would like to introduce about a company from Germany that provides both of LTE-M and NB-IoT service. It's called OneNCE or ONCE. So ONCE is one of global IoT providers, and it offers various data plans, and it also covers wide area network. Makes OneNCE an excellent choice for IoT application globally. And one of the advantages of IoT is its low data usage rate fee. For example, one NCE here only charges for $15 for 500 megabyte capacity. And it can be used for even 10 years. And to put this into perspective, our vibrating wire data loggers with 4 channels, or VW.4, with 5 minutes measurement frequency, only consumes 15 megabyte data. And with this rate, we try to compare with some Taiwan telecom companies, and this rate only equals to less than $1 a month, which is very cheap. And next, I will begin with Sanlien's geotechnical products, which are our main core tools to gather and monitor accurate data. And let me begin with some structure of IoT introduction. So IoT, or Internet of Things, is a system where data is processed and analyzed through a network. And IoT in geotechnical engineering helps us to get real-time data insights without requiring constant manual checks. And in general, structure of IoT consists of 3 layers. The first layer, or front end, or sensing layer. This is where the data collection happens. And in this layer, there are monitoring instruments and data loggers. So the data loggers, after it receives the data from the monitoring instruments, it will transmit it wirelessly through wireless technologies in the mid-level or network layer. And then finally, the data will be transferred to the back-end or application layer. Here is where the data processing and visualization happens. So this slide presents the data loggers we launched before the last partners meeting in 2023. They are VW.4, and WB. Our original model started with VW. And then followed by VW.4, and then we also developed our Wheatstone Bridge data logger, which is WB. So all of these data loggers are all optimized for long-term monitoring. For example, VW. And WB. Can last for 16 months on the batteries only, while VW.4 can last up to 24 months. And even so, all of these data loggers are equipped with battery recharging function. Now let's focus on our vibrating wire data loggers, VW. And VW.4. So as their name suggests, VW. Supports single channel, while VW.4 supports 4 channels. And our vibrating wire data loggers are compatible with various vibrating wire sensors. For example, vibrating wire piezometers, vibrating wire strain gauges, vibrating wire load cells, and etc. Our vibrating wire data loggers are widely used for projects such as deep excavation, tunneling, groundwater level monitoring, and other projects. And next, we have Wheatstone Bridge data logger, or WB. WB. Is optimized for resistive Wheatstone Bridge sensors. For example, load cells, strain gauges, and pressure transducers. Unlike vibrating wire sensors, Wheatstone Bridge sensors rely on electrical resistive changes to measure forces such as strain, load, and pressure. So WB. Is an excellent choice for projects that require high precision and accuracy in monitoring load. And last year, in 2024, we launched 2 new data loggers, Tilt. And Rain. These 2 data loggers enhance our monitoring capabilities by focusing on tilt measurement and rainfall monitoring. Let's take a look on each of these products. First, we have Tilt. Which is our newest digital tilt meter that supports NB-IoT wireless transmission capability. So our Tilt. Provides biaxial modules, X and Y, and Tilt. Can also measure temperature simultaneously. Let's take a look on its specifications. So Tilt. Use MEMS accelerometer as its sensor input. And As I mentioned before, it provides biaxial module, and it can measure up to 90 degrees. Tilt dot has accuracy of 0.01 degree with the resolution of 0.0001 degree. For the power supply, we use 2 lithium-ion batteries with recharging capacity. And next, we have rainfall data logger, which is rain dot. Rain dot also support NB-IoT wireless transmission capability. And rain dot is compatible with various standard tipping bucket rain gauges, makes it compatible with existing setup. And the specifications are as follows. Rain dot measures pulse count from rain gauges as its signal input. And rain dot has measuring range of 0 to 2 Hz, with the power supply also using 2 lithium-ion batteries with battery recharging function. By integrating rain dot to geotechnical monitoring, we can now better assess the impact of rainfall to slope stability and some other cases. And here in this year, in 2025, we plan to launch some new data loggers. We have A.dot, A.4, VW.16, and Shake.dot, which I will now introduce one by one. First, I will begin with our analog data loggers, or A.dot. So A.dot comes with 2 variations, which one supports single channel, we call it A.dot, and another one is A.4, which supports 4 channels. And our A.dot series will support both of LTE-M and NB-IoT wireless transmission capability. And our A.dot series will be compatible with various analog sensors. Let's take a look on its specifications. So A.4, for example, support 24-bit resolution ADC, and with the differential voltage measurement of 10 volts. And A.dot series supports single-ended voltage measurement of 0 to 5 volts, with the current loop measurement of 4 to 20 mA. For the power supply, A.dot series use 4 lithium-ion batteries with battery recharging function capability. And next we have VW.16. As you may have already guessed, VW.16 is our newest vibrating wire data logger, which supports 16 channels. And VW.16 also supports both of LTE-M and NB-IoT wireless transmission capability. And VW.16 is optimized for large-scale geotechnical monitoring projects, which require multiple sensors to be connected simultaneously at a single area. For example, in deep excavation projects, where multiple rebar sensors and strain gauges need to be connected. And the specifications are as follows. VW.16 has accuracy of 0.01%, with the measuring range of 450 to 6,000 Hz. For the power supply, we use 5 lithium-ion batteries with battery recharging function capability. And finally, we have Shake.dot, which is our vibration data logger. So Shake.dot also supports both of LTE-M and NB-IoT wireless transmission capability. And Shake.dot features a built-in triaxial accelerometer, XYZ, and Shake.dot can record the data by trigger or threshold based on some international standards shown in the screen behind. So the specifications are as follows. Shake.dot uses MEMS accelerometer as its sensor input with the channel XYZ. And for the trigger mode, we follow D1 and BS standards for PPV, peak particle velocity, and ISO standard for MTVV, maximum transient vibration value. And for the sampling rate, it is 1000 Hz with the frequency output resolution of 0.12 Hz. For the power supply, we also use 2 lithium-ion batteries with battery recharging function capability. And in addition to that, we are also actively developing some other data loggers. And currently, there are 3 data loggers under development. First, SDI-12 dot, which will be compatible with various SDI-12 sensors. And next, we are developing D-dot, which is digital data logger, and D-dot will be compatible with various IPI series sensors. And finally, we have THP dot, which stands for temperature, humidity, and pressure, but the name is not fixed with THP. And THP will provide real-time climate data for various applications. So in this section, I would like to highlight some key points. First, I would like to emphasize that we are actively developing some new dot series data loggers to provide clients with various monitoring applications. And we are upgrading gradually to NB-IoT and LTE-M, providing more stable communication. And then we are also introducing battery recharging function capability that we can eliminate the limitation of fixed battery lifespan. And finally, we are upgrading to N-type connectors and waterproof antennas that significantly enhancing the resistance in the harsh condition. So in the screen behind, we can see the full lineup of the dot series data loggers for 2025. And in general, our dot series data loggers continue to evolve, providing more advanced, more reliable, and more flexible solutions for our clients with different monitoring needs. Next, let's discuss how our cloud platform works in managing and processing the data. Let me begin with some introduction with how our cloud technology works. So first, our data loggers will transmit the data readings wirelessly through MQTT protocol. And then once it's received, the data will be transferred securely to a cloud platform. And here, there are some formats available, for example, FTP, API, XML, and JSON, ensuring smooth integration with various clients' applications. And the cloud platform will process the data, performing the analysis and calculation. And finally, the processed data will be stored in the cloud. And here, our clients can access the real-time data easily. And they can also generate various reports. And let's take a closer look on our dot system structure, which outline the data flow from our on-site monitoring instruments to various software and cloud platforms. So the system starts with various sensors connected with data loggers. For example, vibrating wire piezometers connected to VW dot, or load cells connected to WB dot. And these data loggers, after they receive the data from sensors, they will prepare it for transmission to a telecom company base station. And this station acts as a relay, forwarding the data to a cloud server. And here there are 2 data management approaches that our client can choose. So in the first option, our clients can choose to host their own cloud by using MQTT protocol, so that the data can be directly transferred to their own built software, ensuring the full data access and control. But there is also a second option, which our users can choose to use our Sanlien cloud platform. And our cloud platform provides several functions. For example, API function, where our users can share the real-time data with their clients. Or they can also use FTP service, where they can also automate the data and transfer the data to their own built software. And of course, they can always use our dot platform directly, which is an end-to-end solution. And now I will explain more about it. So our cloud platform is called dot. Dot platform allows users to check real-time monitoring data remotely. And our DOT is free to use for the first year, and then we only charge like for a few dollars in the following years. And DOT has some key features, which now I will explain one by one. First function, it is obvious that our DOT can provide real-time monitoring data display, so that our users don't need to go back to the site to check the monitoring data continuously. And here is the example of DOT platform main page. So in the main page, our users can check the latest measurement data with, our platform will also show the status indicated with the colors beside to it. And in addition to that, our DOT platform will show the battery level and signal level, along with device's temperature. So all of this information are very useful for our clients to know the condition of their devices at their project site. Next function. So we have this function where our users can choose how they want the raw data to be processed and which unit to be displayed. What they need to do is just inputting the device's parameter in the open fields behind, and our DOT platform will do the calculation and do the units displaying. And next function, our users can also set their own threshold security value. And our DOT will provide instant visual cues indicated by the colors, for example, red as danger, yellow as warning, blue as caution, and green as normal. So when the data exceeds that management value, our system automatically sends notification by email and SMS. And in addition to that, our system can also send automatic notification if the device battery is below 5%. Next function. In addition to see the latest measurement data, our users can also access the historical data for specific time periods. And they can also generate the file into CSV file formats. And in addition to that, our users can also generate the historical curve drawing and print it based on their needs. And next function is map display function. Through this function, map display helps our clients to quickly understand where their monitoring instruments are located. And this is very beneficial for large-scale projects where many sensors are deployed in a large-scale site projects areas. And next, our DOT platform allows users to change the measurement interval through a single click. So now our users don't need to go back to the site to do the manual resetting. And finally, we have API service that allows users to share real-time data with their partners. And then we also provide FTP service where our users can use their own FTP server to receive the data. And I'm so excited to announce a major upgrade on DOT Cloud platform. So our DOT platform is now available as a mobile app, both on iOS and Android platform. So now our users don't even need to open their desktop, but instead they can only scroll through their mobile phone. So if you're interested, please kindly scan these QR codes to download the apps on your mobile phones. I will give you some few seconds. Okay. To close this section, I would like to highlight some key points. So I would like to emphasize that our system is very secure because the data transmission between the data logger and cloud server is securely encrypted. And then our data forwarding function are also securely encrypted using HTTPS and FTPS. And for the settings aspect, open fields are available for all settings, for example, project basic information, physical parameter calculations, and etc. And in addition to receiving the data, our dot allows remote changes to measurement frequency and some other settings. And our cloud also allows data forwarding with various formats are available, for example, FTP, FTPS, XML, and JSON. And our dot, as it has been mentioned before, are available on both web browser on a computer or as mobile apps. And dot records and allow access to data such as signal strength, battery life, device temperature, and etc. And finally, our system automatically sends instant alert via email and SMS for events such as exceeding management values, low battery voltage, and system lease period expiration. And finally, I would like to share some case studies for us to discuss. So the first case, it involves an elementary school underground parking lot where foundation upheaval issue arose. So that our clients installed a combination of VW dot, pumping well, and vibrating wire piezometers. So the result was as follows. In this first graph, we could see the correlation between rainfall intensity and water level. So we can observe here, whenever there was heavy rainfall occurred, there was significant spike in the water level. So according to this graph, our users, our clients, started pumping manually whenever there was water level rise, and they would keep the pumping until the water level drops to normal, and then they would stop pumping manually again. So this ongoing monitoring and intervention helps our clients to prevent further upheaval issue. And then the second case, it focuses on liquefaction analysis monitoring. So our clients installed combination of vibrating wire piezometers along with VW dot. And by continuously monitoring groundwater level in a liquefaction-prone area, our clients can now better assess the liquefaction risk, and they can also make informed decisions on the action needed to prevent further hazard. And this last case, our clients installed the combination of vibrating wire strain gauges along with VW.4 to monitor a cement silo capacity. So the concept is as follows. In the very beginning, they use a traditional hanging rope method where they put rope or stick to measure the empty tank so they could measure and can estimate the weight of the tank. But this was not accurate, and also it couldn't be continuous because they could only monitor it like once a year or like maximum like twice a year. And then so that they also now are asking us like to install automatic load monitoring system where we installed vibrating wire strain gauges on the 4 columns of the tank support base. So when the tank support columns experience strain due to the weight of the raw materials, the load can be calculated by multiplying strain, Young's modulus of steel, and cross-sectional area of the support columns. So the results are as follows. So the top graph shows the difference between the automatic measurement and the manual data record. By the way, I'm saying this manual data record, it was by measuring the weight of the truck which carrying the raw material. So that in the bottom graph, we can see the difference between the automatic measurement and the manual data record. So our system can significantly improve their accuracy in monitoring the capacity and also improving their work efficiency in general. Let's take a look on the project video. So lastly, if you ever require a national telecommunication certificate, Sanlien can help you in the application process. In Taiwan, for example, every telecommunication devices need to obtain permits from our National Telecommunication Commissions before the deployment. So we are very familiar with the process and the requirements. So that's all from me. Thank you for your attention, and please let us know if you have any questions.
Any questions? I have a little thing to add. After we've done the silo project, we realized how rich, wealthy the cement companies are, you know, because usually back then they used the manual reading to track down the loading of the silo. And what we realize is beginning of the month and the end of the month, usually numbers are very off. Maybe somebody stole it, we don't know. But after we start using this kind of method for monitoring, they have better understanding and precise. Like every 5 minutes, they know how much the load is. Because as the picture can see, the silo is not like a perfect shape, you know. So currently there are around 500 silos in Taiwan. So we are in the progress of installing this system to all the silo in all the cement company in Taiwan. Hopefully they can get better and precise reading on what they have, you know. It's kind of important. Otherwise, that's the reason I say they're rich, you know, because they never know how much inventory they have, you know. Anyway, so do you guys have any questions? Oh.
So basically, you converted the column into a load cell, and one of the problems I've been doing a lot of prop load monitoring before, and one of the biggest problem we have is temperature effect, because the temperature effect on the column is significant. So how do you do the temperature correction?
Actually, I was a bit involved. So you actually know. So we have empty silo. So you know when the truck comes in, like how much they dump. So we use that to record rate with every daily to see like the slope of the. So you know 100 tons coming in today, and it should be 100 tons going out. So daily we use that too, because we can empty the silo. So that's how we do not particularly with temperature, but we have a good understanding daily the temperature and also how heavy it is.
And the solution is not just the sensors, but also the whole system, including the software.
Yes.
Okay.
So as like the dot cloud, basically we charge $1 per month, you know. But if you want to set up your own like web interface, a lot of users, they bought our data logger and they set up their own web interface. And one more thing I would like to add is, if you are because NC's every single country has their own communication, whatever protocol or committee. And if you guys are need to get certified, Sanlien is willing to compensate the certification fee. In Taiwan, it's quite expensive, but if other country, other partner, you guys want to get the certificate in your country, we are willing to pay and help you to compensate.
Yes, and we need to have it certified by the National Telecommunications Commission.
Yes.
In order for us to import it properly.
Yes, we are willing to pay the certification if you find a source for us.
So we have an import permit and we have an NTC license to do that as well.
Yes. Yeah. Any other questions? If not, thank you. Thank you, Siri.
Good morning, everybody. To follow up the cloud theme today, this morning, I'm going to look back into the data flow of instrumentation and also the data management system, see how much it changed since I was a junior engineer. So over the 30 years, the collection and processing, analysis, and presentation of instrumentation data has been changed significantly. And basically, because the progress in microprocessor, personal computer, and also wireless transmission and data logger technology, and also the impact of internet. The more modern flow, the modern data flow needs to move vast amount of data between different web-based system, platform, and applications quickly, accurately, and securely. And I remember when a long time ago, a project may have something like 5 sensors, but now a project may have something like 1,000 sensors, which is not uncommon. So in the early 1990s, we're gradually moving from pen and paper to dedicated data loggers. Things like Digital from slope indicator or seismograph. And I still remember the time that the seismograph output is on the thermal paper, and I have to use a ruler to measure it, to digitize, basically human digitizer, and then take the reading. And also, I remember the time I was taking inclinometer reading, and I have to take my survey notebook, put down the depths and the reading, and then work out the result on a table provided a paper form. And but those dedicated data recorders certainly changed the life of most of the people who has to take reading in the field. Then late 1990s, we gradually transitioned into general purpose data loggers, things like Campbell data loggers and data takers, etc., which you can connect it to the system and various sensor, analog sensor, digital sensor, etc. But they require programming. You need to do a lot of programming and also do a remote collection. You have to use acoustic modem. I don't know how many of you remember. You basically dial up and they will go beep, 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 and then very, very slow as well. And that's also the time the PC-based data management systems started to come out, like window-based software to display and using a database to collect, analyze the data. And then we move into year 2000s. The custom wireless link and cellular-based, IP-based modem has come into availability to be used by geotechnical field. And I still remember the time that we got our first Red Wing cellular modem from Verizon in the US. That basically changed the whole thing. But that's a CDMA modem, which is long being won't be taken over by the 4G and 5G modem now. And this is also the time the cloud-based data management systems start to emerge. I remember the first one I've been using is Argus. Argus basically, it's come from Interfell, and it's been taking over from the Windows-based software, and you can log on and make data available all over the world. Doesn't matter where you are. And in actual fact, we still have Argus running for one or two customers. And Christoph only recently retired from using the Argus. And he yesterday actually asked me, he would wish he still have Argus to use. But Argus is retired, and because the technology-based, Argus-based has been, obsolete. It's very, very difficult to manage it. And in 2010, the mesh wireless network, LoRa wireless NB-IoT cloud-based data management system, using like a cloud service like AWS, has come in. And also the virtual machine on AWS, basically you don't need a hardware PC to run the system now. You just can make a PC on AWS, or you make a Linux machine on AWS. It runs faster than actual hardware, what I call bare metal computer. And it's in the cloud. So if something goes wrong, you just put another virtual machine onto it. You don't have to worry about the hardware upgrade and everything. And now we're going to 2020s. And now we're starting to have integrated sensors and readout unit. Things like tilt dot, which is the sensor and the transmission and the data logger. And the various wireless capability. And also, there's a time that the data flow has starting to use things like API, data lakes, and also the software platform like Tableau-based analysis and automated reporting, which I will cover. And this is typical legacy data flow. And basically you have here a data logger, individual data logger. It could be Campbell data logger. And then they connect it to the PC either through hardware or through cellular modem. And data collected on the PC and then push it to a FTP host. And then in the same time, you might have a system like this. This is typical like word sensing. You have node, and they use a local wireless transmission like LoRa, send it to the gateway. The data will be collected in the gateway. And the gateway will be connected to the cellular modem, push it to their own cloud, and then the cloud, it can go to the FTP. Or this one, the gateway will go straight to the FTP. So basically, FTP become the central point. All the data goes to FTP. And then you have a DMS, data management system in the cloud. You pick up the data from FTP, you process it, and then you make it available to the users. And now we're going to a more modern approach. Here you can see this is typically an input that you can take in from by Eagle.io, which you can see besides FTP, download from ITVT, you have a choice of all sorts of options. Like, you can do it from AWS, Amazon, S3. You can do it from Dropbox, or you can email to it. And sometimes you can even SMS the data to Ego. So that makes it quite versatile, but quite bewildering as well. So this is an example of data flow, which we use, we're still using now. One thing you notice is more and more cloud there. This is a cloud-based, 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 cloud-based. So everything is in the cloud now. Here we have air quality monitor. They will be collecting data straight into the cloud, which is Airquote Cloud, and using basically cellular modem. And then we have a software which will collect data from Airquote Cloud using API. Okay, thank you. And then the data can be transferred to Ego.io, again, using the API. And then Ego.io will transfer data to Data Lake, which is a repository for data and various metadata. Here, Ego.io has ability to create report, and Data Lake, you can get data, Tableau can get data from Data Lake and create another report. And those two reports can be merged by another cloud platform called Pushmetrics. Here, you can email the report to individual users. And one thing you notice, we're getting more and more cloud here. So we talk about Tableau and we talk about Pushmetric. Those are the two web apps we use extensively. And Tableau is a very powerful visual analysis platform. And it can be called, it can be considered as Excel in basically superpowered Excel. You can do charts, you can do table, and very easily. And you can make custom report, and you can do extensive analysis. It's a very, very powerful system. And Pushmetrics is a platform you can configure to distribute the data generated with Tableau to the individual users. And it's very important to most of the project nowadays, because even though Tableau can be made available to the user to log in and see what's happening, and they can see the chart, they can see the data, they can see the alarm, but most of the people still like to have PDF report every day, and they don't necessarily open it, but they see the inbox has a report, they're happy. Until one day they open it and see, God, there's all the alarm, and then they're going to call everybody. So unfortunately, that's how the things work. Everybody is busy doing things, but they want the report, PDF report. And automatically, and doing it manually is a very, very resource-heavy task. So using those two software, we can actually automate those. And because the power of Tableau, you can make very beautiful, customized with the logos, with the format they require very easily. And once you've done it, you just set every day, send it to this people, and you forget. And the data lake, data lake is a little bit different from database, because every DMS is based on a database. And then the data will be in numbers or in text. But the data lake has the ability of storing data more than just numbers and text. It can store pictures, unstructured information and images and etc. So it's a much more powerful system, and you can put in all the information relatively to your important, relevant to your project. Because the normal database has a restriction. I mean, if you say, oh, I want to put my report into the database, it's not easy. And if you say, I want to put my email information into the database, that's not easy either. But data lake, you can link them all. So basically, they were designed to support a wide range of analytic, and including data processing, machine learning, and real time. And now everything is AI. So data lake become very important resources for the AI. And now we're going to talk about, we have so many clouds, how the cloud talk to each other. Now, how are you going to get data from the cloud and push from the Oracle cloud and push into Eagle? And they have to have a common language. And one of the problems of different platforms is they all use a different database. Somebody use MongoDB, somebody use Microsoft SQL, and somebody use also the MySQL, etc. So they all have their database, and they all protect their database very, very securely, because if they give you access, you mess it up, the whole system gets messed up. So what they do is they use an API, which is called Application Programming Interface, which is a set of rules and protocol allow different software applications to communicate with each other. So it doesn't matter what kind of database you use. You can use this API, and you can get the data, you can change the data, but without mess around with the core database. And for example, when you use a weather app on your phone, it will use the API to fetch the data from a central storage of weather data, but you don't have to have all those databases on your phone. And some of the nowadays some of the web platform, when they developed, they actually develop an API first, and then build a user interface on top of that. And those are the more modern approach. But some of the older one is afterthought. They have all the user interface, database, everything done. And then people ask them, do you have API? They will put a layer of API on it, which is a lot more restrictive. And the advantage of API is here, mainly is the security, scalability, and also you can control which version you use. And the people who provide the service, they can make sure the system is secure and not being messed around by the user. And what's the components of API? API, what I call endpoints. Endpoints, basically, they provide you with the result you want. You can make an API say, how many instruments I have? And then after you find out the list of instruments, you say, I want to know about detail about this particular instrument. And once you know that, and you can say, okay, I want to know the data from this instrument between this day and this day. So they will all come out for you. And then you can use those information directly into your own management system, or even like Tableau, or you can use it to send it to someplace else. So the endpoint is the target, and then you get a method, and you use a post, or use a get, or post, or put. Basically, you can just get the data, read only, or they allow you to make changes. You create a new sensor, and you create a new sensor style, sensor type, etc. And you can even push data into it. And they have a request header and the body. And then when you come back, they have a response header and response body and the status code and authentication. Authentication is very important because not everybody can use the APIs because some of the people, some of the platforms, they charge for API access. And some of the platforms come with API access. So they need to make sure only the authorized people can get the API. And this is an example of an endpoint of Oracle Cloud. And basically, you can get it. Calibration information, you can get lists of instruments, and you can, basically first thing you need, obviously, you need to log in with your password and API key, and then you can go into settings, and you can delete and modify user, add users, and this is where we're most interested, is getting the data. Okay. And this is an example of API request. Basically, you put this in your browser, and you press enter. This is what they respond. This is basically you request a list of instruments. And every platform has slightly different format, but the general idea is similar. And how does the API, the API has its own language. Their language is basically JSON. JSON is developed, it's called JavaScript Object Notation. It's a lightweight data exchange format that's easy for the human to read and write, and easy for the machine to parse, basically to understand and to generate. This is some example. Now, JSON basically has JSON object, which is enclosed in the squiggle parenthesis, and here you can say the name of the person is John Doe, his age is 30. And there's also an array. It's a square parenthesis, and then the list of value underneath it. And you notice that JSON, one of the features of JSON is they use a lot of double quote, and they use a lot of squiggle, curve, bracket. And the thing is that square bracket can be inside the big bracket, and then the big bracket can be containing a square bracket. So basically, it goes down and down depending on how detailed you want to get very, very detailed. And for the application we use mostly, we have a lot of time series data. Basically, all the data has its own time stamps on it. So JSON, they actually have a special format called JTS. JTS is called JSON Time Series. And that's how VW pushing the data using JTS. And the JTS includes what's the type, the header. Header will tell you starting time, end time of the data includes the later. And then you have how many record count, and column tell you, okay, the first column is temperature, second column is name, the third column is a number, and then you come with rows and rows and rows of data, which can be tens of thousands of data. But for the computer, it's very, very easy for them to understand. Okay, now we're talking about cloud, and now we're starting to have cloud-to-cloud data flow. Here, the blue ones are the ones which generates the data, what we call source. And then the yellow ones are DMS, and both they can output data and intake data, import data. And the green one are the DMS, data management system. How are you going to make them work? You know, some people want to say, okay, I have a load sensing cloud. I want to go to Eagle. So you go to a central hub and go to Eagle I/O. But they say, okay, in the same time, I also want to go to BDB. Okay, you can go down there and go to BDB. So try to do that one by one is quite extensive work. So what we need is like a central hub, which basically, I understand what data come from. I understand what they need. So let's do a target, do integration here, a source integration, target integration, and then here we make a pipeline through here to here. And already made a target integration. Basically, we made integration of all of them. Some of them source, some of them target. And then we just have to pair them together. The pipeline might go here, my pipeline may go there, and may go from there to here and go there. So the traffic is much easier to manage. So this is a new software, which is a new platform, which is called IMSurge. It's no code, SaaS. It's a software as a service. So platform that move data between the platform. And basically, you don't have to worry about the API anymore. You just provide the API protocol, and some of them they already know. And then you just set up integration and set up pipeline. And then the data will just go as you wish. And the main thing is they will take care of all the code. Take care of all the code requirement. You don't have to worry about any of those. And next page, yeah. So next page is a video on that.
So, you want to do real-time instrumentation monitoring. You have the monitoring and reporting software. Great. You have the sensor hardware. Awesome. You're good to go, right? Not necessarily. Unless your hardware and software are specifically designed to work with each other, you're still left with the problem of figuring out how to make two products which were not designed to work together. The solution is not always easy. Traditionally, it's done by deploying a fleet of data collection servers, hosting a collection of custom data batching, and processing utilities. This may work starting out, but as infrastructure projects grow in complexity, the monitoring demands grow to match. Today, instead of collecting a few thousand readings a day from a few dozen sensors, you might be collecting millions of readings a day from thousands of sensors. If your backend solution doesn't offer you a reliable and scalable solution, it can result in delays to alarms and reports, or worse, complete loss of data, upsetting your clients and making you look bad. IMSurge is a different approach to this problem. We reimagine data collection as an event-driven process to streamline inter-device communication. This allows for universal compatibility across all vendors supported on our platform. We handle the collecting, batching, and processing of data in a real-time, scalable, cloud-native environment. We also work with vendors to develop the fastest and most reliable collection methods possible. Simply register your products as integrations and link them together in pipelines to set your data in motion. No more reading API documentation, writing code to parse proprietary file formats, and reverse engineering communication protocols. Getting data from your sensor to your monitoring platform with IMSurge can be done in just a few clicks in the management portal, freeing up valuable time for you to focus on interpreting data and providing meaningful reports to your clients. IMSurge, a real-time solution for real-time demands. Get started with us today at imsurge.net.
For full disclosure, IMSurge is my son's project. He's working on that, and in collaboration with Spectral Technology, which we use their service significantly, and we give him ideas what we want, and he will created what we want, and then he's hoping that he will get more and more usage from different platforms and different users. Thank you. Any question?
Any question for Dr. Hai?
Great presentation, Dr. Hai. The IM search. So what do you think about it? Because when you look at it, the sensor manufacturers, they have their own clouds. Let's say like load sensing, and they push it to IM search. Then the rest of it, like Sensely or Argus, then that becomes just a dashboard, isn't it? Yeah. You know, and anybody can just create some dashboard and basically work with IM search. So this system can obsolete that part of it. What do you think?
No, the DMS is more than just a dashboard. It does alarm. It does trigger alarm and things like that, which IM search doesn't do. IM search is purely just transport data from one place to the other.
Yeah.
And the,
yeah.
the value of IM search is something like, now if you're stuck with one platform like VDV, if you use them, and suddenly you find they stop, what you're going to do? You know, previously you spend a lot of time, a lot of effort, write a software to make the data import into VDV, into that specific format. Now suddenly you are forced to change to iTwin or Eagle.io, and they're stuck. But with IM search, you just automatically change the pipeline, the data goes there. And also, if you have the need to have a time to migrate from one to the other, you can actually send the same data with two pipelines, one to VDV, one to iTwin, until you fully migrated. Then you can just cut off the pipeline to VDV. So that's the simplicity of it, yeah. But it doesn't cut out the DMS.
Thank you.
Thank you, Dr. Hai. On the cost point of view, if I have 1,000 sensors, what do you think? How much I should pay? For every month, because nowadays every company, doing this SAS, even in Windows, doing the same thing. So, what's the estimation you think?
You only pay for the pipeline. You don't pay for the integration. You can have as many integration there as you want, but you only pay for the pipeline, because pipeline actually take resources from the AWS, because everything is based on the AWS. So I think at the moment, if you're using like just limited number, something like 10 or 20, each one is about $15 per month. Yeah, 15. But the thing is, once you start having more and more, the price obviously go down. Thank you.
Hi guys, I'm Carlos from SensorGo from Mexico. Before I start the presentation, I just want to talk about a little bit of our company. At SensorGo, we are a distributors from Sanlien at Mexico. We also distribute another brands of equipment. Not a seismic sensors, but a lot of equipment for the electric utility, mostly, because that is our first principal customer that we have in Mexico. We have a lot of good relation with them. And we have the opportunity to sell these sensors to them for the power substation at the distribution side. As you know, in Mexico, we only have one electric utility that has generation, transmission, and distribution lines also. They own all the distributions, the stations. So, as you know, we are in Mexico. Mexico is a highly seismic country. So we saw that opportunity to offer our sensors that we have from Sanlien to protect the assets of the substations in Mexico, so they know exactly what will happen if we have an earthquake. And we saw that in 2017 when it was a big earthquake. And some of the substations suffered some very good damage, so they have to be repaired. But that's not only the important thing, because regarding that, they can do some automation so they can control and power off the lines to protect people. So it's a very interesting project that we have been working on that. CFE, it has 16 business units, if we call it like that, for the distribution area. So right now we are working with 2 of them. They are Mexico City's south, because Mexico City is too big, is divided in 3 of them, and central south part of Mexico that covers Guerrero, Morelos, and part of Estado de Mexico, 3 states from Mexico. The one is the biggest one. They have earthquakes like Guerrero, that we have Acapulco over there. As you see, there's a lot of seismic activity all over them. That was into 2024, last year. As you see, it's a lot of that. We have right now covered this part with the sensors that we have for this solution that we are working with the electric utility. So what we sell to them, we sell them the pALERT. It's not only the sensor, we sell them on a cabinet with a power supply, with the batteries for the backup, so they can install. We only sell the equipment, we don't install the equipment, we don't deploy anything. Only if we have to, then we can hire someone, another company to do it, but SensorGo doesn't have crews to do that exactly. So what are we doing? All of them have the communications, all the substations, most of them have LANs, Ethernet communication through the fiber optics of the substation for the protection of the relays. So, and they report directly to the master control unit, so they have an SCADA system. In some of the divisions of the business units, they use the DMP3 protocol that is mostly used on the electrical companies, and also Modbus. But in the one that they have Modbus, that's really easy. We just deploy, connect it, and they add it to the master. But in case of the ones that doesn't have that, we use another software so we can translate from Modbus to DMP3 directly. So they can put all the information through the SCADA so they can see it. So this is just the general communication diagram. Sorry, I think. As you see, is the pALERT, the SCADA RTU, or we can connect it directly to the network. It goes directly to the network CFE. CFE is the name of the company, and they have the units, the master units that they receive all the data. Okay. What is the whole idea? The whole idea is that they, using this data, all the information and algorithms, control algorithms are in the master central control unit, so we don't do anything regarding that. We only provide all the data. We will help them to integrate the data to their system, and we help them and giving all the training so they can program the sensors. Okay. And I say right here, we have 4 phases. Installation, I would say all these sensors have been installed by the CFE crews in both of the divisions. And all the integration and softwares and algorithm, we have helped them to do that, but they are their software, so they are the ones in charge of doing all that definition. Okay, right now we have 250 pALERTs installed in both of the divisions, and we are working to have maybe another 200 installed in the other divisions that they have more, like in Oaxaca, Chiapas, that are really, really big seismic areas. So that's why we are working on that. This is an example of the Acapulco area where they show us how the sensors are deployed and they are online, so they can check that everything's online. They're receiving all the data. They receive the data every second. So that's what they're looking for. And if there's an earthquake or a seismic sensor, they can saw that instantaneously on there. And what is also the whole idea, to have a intensity map to know which of the substations can suffer more damage or can be power off, so they can send the crews and to have a quick response to power on again and see what is the damage on the city. This is some examples of how equipments are deployed. Like I told you, we put it on a cabinet with a power supply and a battery. We contract another company to do everything like this. We only we send them the diagrams and they do everything. Okay. So that was for one of the case studies that we have for the electric utilities. We also deploy this equipment, also the pALERT, but for school. This is just for seismic protection in case of an earthquake. They can sound with an alarm saying that it's an earthquake taking place. This is in Chiapas, a southern state that we have with a lot of seismic activity. This was in 2001, I think so, that we sell this equipment. They go and tender this, and we supply almost the same equipment from the CFE project, but the difference is that we have also an amplifier and speaker, so they can alert all the kids. This is elementary schools, okay? And right now we are working and trying to get more of there's more schools in the States, so we can alert them in case of an earthquake. This is the diagram also, and an example of the speaker. Some of them, in this case, they don't have, all of them that doesn't have communication, so it's just a standalone system to alert that there's an earthquake taking place. Okay, it's a quite different application than the electric utility. Okay, and these are also some of the examples of the deployment. In this case, we have to deploy because it's part of the tender. So we hire a company to help us in all the installations. Okay. And that's all. All right. Thank you. I don't know if you have any questions.
Anyone have questions? Hi.
Thank you for the opportunity, Mr.
Carlos.
Sorry, I wanted to ask about the part that you said that to differentiate between the blasting and the earthquake. So I wanted to ask, how do you do that? How do you filter the blasting and the other noises compared to an earthquake? Do you do it by filtering through software or through hardware?
Just the software, using the programming on the pALERTs, using one of the algorithms. And in some of the places, they really want to have really high thresholds on the acceleration because they don't want any false alarm. We have been triggered also monitoring that, and they have maybe in some places 50 counts of accelerations. So because they don't want it to have any false alarm, or in some places there are earthquakes even daily, but the small ones, so a little bit that they are too used to that, so they only want to have an alert when they are really, really big one. That's the people get used to that. Okay.
Yeah. Thank you very much, Mr. Carlos.
Welcome.
In your first case regarding this protection for distribution, this station, so I saw that this pALERT just transmit the data to a device called RTU, right? It's via a serial port or
no, the Ethernet.
Ethernet.
Yeah, everything is Ethernet.
As I understand that the pALERT has the capability just string out to the center, right?
Yeah, yeah. In some cases, we don't use the RTUs. We go directly to. They have only a switch, an Ethernet switch, and we just connect it. In some cases, we use the RTU.
So the reason they need this RTU is because this RTU also control the other devices on the station.
Correct.
Okay, thank you.
That's why.
Any other questions? If no, thank you. Thank you, Carlos.
Thank you, Chen.
Good morning, everyone. It's my pleasure to be here today at Sanlien 2025 partnership meeting. Yes. I would like to start with expressing to my class, to all of you, to taking time to be here today to join us. My name is Brendan. With me is Johnny, our main software engineer. Today, we will introduce Sanlien's software. Today, I want to share with you 3 topics. SunDust, improve and update. Suncast app, Sanlien's broadcasting platform. Web GUI, new UI and UX design. First, SunDust. Most of you probably already know, familiar with this software. It's using for analyzing and configuring vibration-related products. We have made major improve based on the market demand and user feedback. SunDust now is faster, more user-friendly, and better suited to real-world applications. Next, we have Suncast app, designed to receive data message from products like PX01 and Cube. This helps users quickly understand real-time and on-site conditions, and will soon be available on iOS and Android. Finally, we will introduce our brand new web GUIs. This upgrade replaces the old complex config file setting with more straightforward and modern interface. Our goal is to make the system more straightforward and flexibility and visually streamlined. SunDust have evolved like living organs, becomes faster, smoother, and more inclusive over time. Next, I will show you the key feature for driving this improvement. Let's start with how we made SunDust faster. To improve efficiently safe storage, SunDust now offers a custom .sas binary file format as an additional option to the existing text-based logs. This reduces the file size significantly, making data precise and much faster. The header now defined as a JSON file, making integration to other applications more flexible and scalable. SunDust supports integer, float, and double data type, ensure efficient storage. For example, streaming straight flow value can be 44 bytes per entry. The differences is grow significantly with the channel and time records. Like before, if you want to save the 6 digits on the right side, 15.363, before you have to save as a stream. So that means will be 48 bytes. But right now, if you save as a flow, that's only 4 bytes, and that will be 44 bytes different. Previously, SANDAS only can display 108 channels at a time. Now, we expanded to over 300 channels to give user real-time overview. This allows better data visions without switching views, improving monitoring speed and decision making. Even with the more channel, the performance remained the same as before. SANDAS now supports mini-C streaming in a well-used format Seismic system, in the Seismic system. This format ensures efficient data transformation due to the small size optimized performance. Sanlien's products have long-term providing mini-seeds and integrate to our system. Similarly configured in pALERT 8 file, start with the Python program and press function 4 in SANDAS to start streaming in data. SANDAS now make efficiently absorb real-time frequency domain data. With just a double click on the graph, the toolbar appears on the upper right corner. You can easily switch between frequency domain, time domain, and view both simultaneously. This provides more straightforward and efficient way to analyze data in real time. Next, let's expression SANDAS enhance and web GUI integrate to our even smoother experience. SANDAS now including built-in web functionality with a direct device setup, making configuration more convenient within an application. It also integrates Sanlien's latest web GUI, offering modern user interface. This provides users having more flexibility, allow them to choose the method, the best way to fit their workflow. SANDAS already support virtual signal analysis and vibration standard using across industry. Now we have taken the step for even further by integrating seismic design standards to enhance safer and complete. The feature was initially required by customer in the Philippines. However, the line with our inclusive principle, we extended this feature. We have incorporated all available seismic algorithms from multiple countries, ensure SANDAS meets international standards. Next, let's talk about the platform compatibility, including Linux support. Thanks to the web browser-based architecture, SANDAS can be easily set up on any desktop operation system. Originally only available for Windows and Macs. Right now, we expand the support to Linux due to the customer demand. As shown as the image, SANDAS can run smoothly on SenseOS, ensure the reliable and experience across the platform. With the improving speed, easy to use, and inclusive coverage, this now explored to our brand new application, Suncast. Sanlien is actively expanding into mobile application to enhance real-time monitoring and accessibility. Suncast is a dedicated mobile internet broadcast solution designed to receive stray message from the Sanlien's products like PX01 and Cube. This is available for both iOS and Android. The key highlights for this is Suncast is completely free to making accessible for all users without any cost barrier. Next, let's take a closer look to the application. Currently, many users receive text-based alerts through Line Notify. However, the Line Notify being phased out, this functionality is becoming more limited. To ensure long-term reliable, Sanlien developed Suncast as a dedicated solution. Instead of raw text message, Suncast transformed notification into a clear graph interface. This makes much easier for customer for real-time data and react accordingly. In the future updates, Suncast will expand beyond Seismic events to support multiple application scenarios with troll alerts. Next, let's explore our new interface. Suncast follows Sanlien's software long-standing user-friendly design principle. We focus on keeping the interface straightforward and easy to navigate. Subscribing the alert is simple. Enter the product serial number. No need to having complex configuration. With a few clicks, the user can start receiving real-time notification directly. Next, let's dive into our new GUI. Sanlien has redesigned the web GUI, offering clear and more straightforward interface. Before the new web GUI, users have to configure settings through complex text-based file like this. This requires manual editing of configured files, increasing the chance to having error and making setup time-consuming. Even small adjustment require reaching through long list parameters, making it difficult to non-technical user. This approach will high chance for misconfigurations. Now let's compare to our brand new web design and how easily it can be used for everything. And these are brand new web GUI login page. And user can be easily logging through this page and set up a different language. And in this page, on the left sidebar, you can see a very clear parameter setting under the setting for details parameter settings. Here is our brand new parameter setting. Here, the user only have to choose the function they need from here. For example, for today's example, we're using event. And this allows users having a clear understand and clear way to choose what they want to configure later. After event settings, click next will be seeing this more detailed configuration. And all the configure will be based on the default setting or the default vALERT setting. And here, the graded part will be the disabled part, and the blue highlight part will be the enabled part. And here, on the very top, event setting, that will be the function name. And API config, that will be the main title. And on the left side part, you will see the earthquake API, that will be the subtitle. And here, on the graded part will be disable, and button will be enable. Yes. Here will be having a detailed look for every setting. On the left-hand part, you will see the small click box, and it will be allow you enable or disable the parameters. And on the side will be the subtitles, and down here will be having description, so the user can easily understand what's the parameter setting for. And on the right part will be the parameter setting, and user can easily config by clicking in to change to yes or no. And on the bottom will be the range. So for this parameter, only can choose yes or no. So user is not allowed to having any other config. And here we'll be using another example is the SHM settings. And SHM settings here having two different showing. For example, on the top part, the user enter -1, and that will be out of range. So the system will notice this. So it won't let user to save this configuration. And if the user see this, it can be easily noticed, like the parameter is wrong, so they can follow the range and the description. On the bottom part is, if the user didn't enter anything, that means this parameter is being disabled too. So if the user save this configuration, it will be known as no. So the parameter won't go through the system, and you won't have any error. And lastly, here, after all the config, user will be clicking save. And after clicking save, it will be on the right-hand part, will be the notification for the user. And the user can click OK or yes, or cancel for yes, and cancel for no. And if clicking yes, will be rebooting the system. So that means we're pushing all the value or all the parameters setting to the device. So the new setting will be pushed on. And if you click no, it will be setting safe, and you require to reboot after change. And the left bottom part will be the loading for user. So user can notice is the system are booting and loading. Thanks for everyone's listening. And here's the QA.
Brendan, any questions for Brendan? If no, thank you, Brendan and Johnny.